Max 1 revision session, the second revision session we have today. So let's wait 1 more minute. Let me settle down all. Then there were a technical glitch. Now it is resolved. So the last revision session is on, right? It is done for week 5 and 6, no? So we will today do. So today we will do for 7 and 8.
Okay, sir.
Okay. Okay. Present my screen, then we'll start the session. So what we will do, we will do the revision, like we will try to revise the concept today, and then we'll do some activity or graded problem based on whatever we revised. I will take such a problem so that you will get a what are the, like it will be similar to we have done already the mock also, and mock solution is still meant to upload, no? Tomorrow have already mock is ended. Okay, need to upload. Okay.
Mock is uploaded, sir.
Okay. The mock, this mock for quiz 2 solution is uploaded.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Yes.
So when will reattempt session start?
So reattempt is already started.
No, sir, actually it's not joining. The meeting is not getting joined.
No, please refresh your calendar. Actually, I have updated a link there. So please refresh and update, join the updated link.
Okay, sir. Okay, thank you.
Yeah.
Sir, can you list out the standard limits?
Yes. So let me present my skill, then we'll do one by one whatever we have. Okay, is that?
Sir, please revise from the basics of week 7 and week 8, so it will be helpful.
Yes. Yes. So hope my screen is visible to all of you, no?
Yes,
sir.
Yes.
Okay. So let me start. So week 7 and 8 is and 9 also. Week 7, 8 and 9 are all our calculus portion, but week 9 is actually contain the critical points and differentiability. Differentiability also there. No, differentiability within week 8. Just a minute. Let me go. The critical points and maxima minima integration is in the week 9.
Sir, in quiz 2 it is week 5 to 8, right?
Week 9 we don't have for
Week 2 is week 5 to 8, and week 7 contains the limit of sequences and the limit of function, and week 8 contains differentiability, exactly the whole limit of continuity and differentiability. So one by one we will see that. So in the first lecture, the whatever the topics, like topics of maths, it is just revising the different type of functions. So there are linear functions, quadratic functions, and different type of function. We have polynomials and trigonometric functions.
So, am I audible, sir? Sir?
Yes.
Sir, like I have a doubt.
Just a minute. Yeah, you are audible.
Yes, sir. So I have a doubt that in this session, what are the week syllabus are we
Yeah,
going
what's
to
your doubt?
cover it? Sir, in this week, what are
Week
the
7 and 8.
Okay.
Hello, sir.
Yes.
Sir, please explain this limit of sequence, sir, like in detail.
Excuse me, sir.
I think sir is having some issues from his side.
Yeah.
You are muted.
Yeah, I guess sir is muted.
Just a minute.
Okay, sir.
Yeah. I just got a call. Yes. So what's your doubt?
Sir, could you please focus on the basics too, sir?
Yeah. Let me start. Then we'll
So can you
everything
clear
one
week
by one.
7 and 8 revision because week 5 is Jamil and yesterday.
Sorry. Yeah. So we will do the revision for 7 and 8. Okay. So just a minute. Okay. Sorry for there were 3 sessions is actually happening, and all 3 have some issues. So let me start now again. So okay, this is okay. So in like in the first lecture is topic. Am I audible, right? Is it my voice is
Yes,
clear
sir.
also? Okay.
Yes, sir.
Yes, sir.
So so different type of function we in the first lecture it is that is quadratic, polynomials, and trigonometric. Trigonometric function is also there. So let's revise the trigonometric function. So the trigonometric is actually that sine cos function. Okay, the sine theta, cos theta, sine theta, cos theta, tan theta. So only these 3 functions are enough to know that. So this is actually arrived from the right angle triangle. So you know the Pythagoras theorem or Pythagoras theorem is there, whatever the pronunciation you want, you can give. So there is a Pythagoras theorem, which is, let's say this is A, B, C, okay, and this angle is 90 degree, and suppose this angle is theta. So this sine theta is nothing but just dividing this AB, okay. This sine theta is AB upon this AC. This one and upon this one. Okay. Similarly, cos theta is, so you just need to once remember it. Okay. I will tell you, I will give you some formulas also here. So this angle is actually whatever here is theta is given. No, if you are worrying with the trigonometric function, so no need to worry. Just to know that okay, sine theta is just think about okay, just go to this right angle triangle. Okay, just go to the right angle triangle, and theta is just take the sine theta. Sine theta is just nothing but this length, this whatever we have, this line length of this line and this line AB upon AC. Cos theta is
by hypotenuse.
yes, and this cos theta is this base and hypotenuse, which is here is AC, and this tan theta is AB upon BC. Okay. Sorry, your voice is breaking. My voice is clear, right?
Yes, sir.
Yes, sir.
Yes.
Okay, so these 3 is only we have. Only these 3 will know. So what are the use of this one is that just need to remember, or even it is if it is used in the in quiz, or even you have seen also in graded or practice. So surely that theta's value is surely given like sine theta. So let me write here also 0 is, suppose this 0 is 0, this 0 is 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. And suppose this is sine theta first. So sine 0 degree means 0. Sine 30 means 1/2. Sine, this one is we have to remember, but if it is in the quiz have asked these problems like sine value, cos value, surely the value will be given. So no need to worry. But it's better if you can remember also. So we are actually doing the revision session. So let me write here so that it will be revised if you are forgetting something. And this is root 3/2, or this is 1 upon root 2, and this is root 3/2, and this is 1. And with the cos theta, cos 0 is 1, and cos, this is in the reverse form, just reverse. Yeah, it is in the reverse form, and this is 1/2, and see that this is exactly in the reverse form. And tan theta is this is 0/0 will be 0, and this is 1 upon root 3, and this is root 3, no,
1.
oh sorry 1, and this is root 3, and then it is infinite. Not, the value is not defined at 90. So these are the trigonometric function. And see, if you see the limit or something like the property, let me tell you these are the values, is not much important. Only need to know the properties. The properties will be clear once we know the graph of the, see, if you have problem with any function, if we know the graph of the function is like open kind of. There is nothing now remain to any property will be remain, like you are now the graph of the function. No? So let's discuss the sine graph of the sine function. So sine function is actually a periodic function, okay? And this is a periodic function. So suppose this value is here is 0, and suppose so one thing I want to tell you that this is in degree, no? This is in degree. This angle is in degree. Okay, but we can change this degree in the radian. Why we needed this radian format? We of these angles. The reason is actually this is in degree. This is in unit. This is in degree format. But once we change this degree in the radian format, it will be applied on the real number. That's why we used to generally change in the radian format. So, and there is a formula to change. If suppose 0 theta, degree is given, so that could be written in the radian format is theta into pi upon 180. No, this is correct one to change in radian. Okay. So if it is any angle is given in degree, you can change in radian. So why we needed radian is because we are in real line, and real line is actually these whatever the numbers we have, it is in the not degree, it is in the real number, like there is a change in the measuring concept. So these are in the real number. So that's why if we change in radian, so it will be behave on the real line. That's why we generally change the angle from degree to radian. So suppose here is 2 pi, okay, and here is here is the pi. Pi is actually 180 degree. Pi means pi radian means here 180 degree. So suppose here is pi and here is minus pi. Okay. So the sine value, the graph of the sine function is, suppose here is 1 and here is minus 1. Okay. So graph of the sine function is at 0, it will be okay, at, and let me write in the bigger format. This is pi by 2 and this is pi, and this is minus pi by 2 and this is minus pi. So at pi by 2 means what? Pi by 2 means 90 degree. If you see that here, you just need to divide. If you do here, which is 90 degree. So at 90 degree, we just now seen that the value of the sine is 1. Similarly, in negative side, it will be minus 1. So if you see the graph, it will be like this. And at pi, it will be 0, and at minus pi, it will be also 0. So this is it is a, see that this function, the sine function is actually a 1 or injective in period minus pi to pi. And now onward, it will be repeat. Exactly, it will be repeat. It will be like this. It will be like this. It will be never go beyond of -1 and 1. Okay, the value of sine is never go beyond of 1 and -1. So sine value, if you in other word, range of sine function, range of, now this x is in the radian format. Okay, this x is in the radian. So now it is in sine function. So sine function, so range of sine function is -1 to 1. You can see the range is the interval -1 to 1. Okay, this is the sine function. And the graph
what is
of
the
the
domain for the function?
And domain is the whole real number. Now see that there is no break, it is a continuous. And also let me tell you, sine function is continuous. Okay, it is a continuous function. Limit at every point exist. Limit at every point exist. Okay, it is continuous at every point. Please everyone mute yourself. And oh God. And it is differentiable at every point. Okay, sine function is differentiable at every point of the real line. And this all properties is cos is the just now whatever we have, the cos function is, you know, at 0 the value is cos value is 1. Okay, so see that at 0 this is the graph of cos. So again this is suppose pi by 2, and this is minus pi by 2, and this is pi, and this is minus pi. So at 0 the value is 1, and pi by 2 the value is 0. Okay. Now again it will be this side, and this is at minus pi by 2 is again 0. Okay, I'm making mistake. Yeah. So here is minus 1, and here is it will be back to like this. So again in this range is sine this minus pi to pi the cos. This is the cos x. So cos in this range it is in this range it is in this minus pi to pi is actually the cos function is injective. Now after onward it will start repeating like it is a periodic. Again the whatever the value is will be continue like this. The same value will get. So again the cos range of cos function is again this x is in radian. So cos range is minus 1 to 1. Okay. So the cos value will never go beyond of 1 and minus 1. Okay. And again this the same whatever the limit at every point continuous differentiability it will happen with the all each point. Okay. And now the tan theta is, so just now we seen that at pi by 2 the function is not defined. Similarly at minus pi by 2 the function will not define. So at pi by 2 and minus pi by 2 will be work as a asymptote. Okay, at pi by 2 the value is not defined. So at pi by 2 and minus pi by 2 work as a asymptote, and the value of tan 0 is just now seen in the distance. I'm referring here this table. Okay. Tan 0 is 0 and tan 90 is infinite. So that's why as pi by 2 the pi by 2 is 90 degree. So again it is a so pi by 2 is going to be a asymptote. So the graph will be like this. The graph will be like this. Now again the same value it will be will start repeating here. So again suppose here is pi and here is 3 pi by 2. Okay. So again the same range will continue here and the graph will be like this. Okay. So here is we can see it here the domain is, and the domain minus pi by 2 minus pi by 2 minus pi by 2 to pi by 2 in this domain the function is actually injective. Okay. And even not injective, bijective, sorry, bijective I'm saying. In this function the function is injective. Okay, not bijective, injective it is 1 the function is 1 and also you can say it is an increasing function in this range.
Also, that's not okay also.
No, sorry.
Sir, the minus pi by 2 and pi by 2 will not be closed
Because it does
intervals.
not obey horizontal test.
Sorry, please one person one. So it's in this minus pi by 2. So here it will be not closed, it will be not a closed interval, it will be open interval. It will be open interval, and in this interval the function is going to be injective. In this interval function is going to be injective, as we can also check with the drawing the horizontal line. Okay, this is the mean. So in this range only, in this domain, in this subset of minus pi by 2 pi, in this range it is going to be injective. Okay, and the range is of the tan is going to be what? Minus infinity to infinity. That means whole real number. Okay, range of tan is going to be whole real number. It is not bounded. Okay, it is unbounded. As you can say, it is going to value is actually going to be minus infinity to plus infinity. Okay, so it is not bounded, but sine function and cos function is bounded. If you see that the range is here. Okay, range is actually bounded in the interval minus 1 to 1. So maximum value of the cos is 1 and minimum value is minus 1. Similarly, sine is also. And again, the tan is also, you can say, the limit continuous differentiable infinite time, means a limit is exist at every point except this, you can say pi by 2. Okay, except this point the limit is not exist, otherwise it is limit is exist continuous and okay and differentiable. So this is all about the tangent. Okay, once you will spend time on okay, some formulas are there. So let me write about the trigonometric some formulas we have. So
Sir, can you tell
like
about the domain of
sine
tan?
square x plus. So domain of tan is, you can think in this domain. In this domain function we have some bijective thing. Okay, in this domain the function we have like a bijective. Even bijective I will say. On 2
Okay,
also.
sir.
Okay, in this domain only. Minus pi
Yes,
2
sir.
pi 8. So this is one property. This is true for any real number. Okay, this is sine. Okay, this is sine square x plus cos square x is 1. This is one property between the sine and cos. And another is sine 2x is 2 into sine x into cos x. Okay, and cos this is one thing. Cos 2x is, what is the cos 2x? 1 minus sine square x. Sorry, 1 minus 2 1 minus 2 something is there, or 1 minus cos
1
square.
minus 2 sine square x.
1 minus 2 sine square x. And also it is differently written in the cos format, no, which is 1, sorry,
Sir, it
2
is
cos
also
square x.
actually cos square x minus sine square x.
So, and also cos square x
Minus sine square x.
sine square x. So there are 3 ways we can write, by this way, or this way. And these all actually generated by this. You can see that sine square can be changed as 1 minus cos square. And cos square can be changed as a 1 minus sine square. And if you see, if you substitute here 1 by 1, you will get this one. So main formula for cos 2x is this one. Using this, these two are actually generated. Okay. So these two are actually important. You can say this one, and this one. So we'll not see the similar. I am here just telling about the some properties of the trigonometric function. Surely I'm expecting that if it is a trigonometric function is used, something surely will be given.
Excuse me,
If
sir.
you, sorry.
Yeah, so sorry to interrupt you, but if you could ask the reattempt session, sir, to just allow us, because from since half an hour we are waiting, and he's not allowing to get in the meeting. So if this could be possible.
Okay, just a minute. Just a minute then. Ganesh, please try to admit on,
Thank you,
because
sir.
I
Thank
am
you so
just
much.
getting that somebody is waiting. So try to, if you are getting notification, frequently come and join them all. Okay, this is one
Yes,
problem.
sir. He allowed us. Thank you so much, sir.
Okay. Yeah. Yeah. Try to keep checking. Okay. My screen is visible to all of you, right? Okay. So, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Okay. So this is the some property of the trigonometric function. Okay. Now let's come to the main, which is sequence. Okay. So sequence is sequence is not as you studied in the in 12th, if you are did maths in 12th. Okay. So there you have seen that the terms like 1 or maybe 2, 4, 6, 8, 9, this kind of arithmetic series were there, the geometric progression, arithmetic progression were there. So that is one sequence we know. And actually that is, you can say, a part of the here, whatever we are studying here, no, that is a broader case. And whatever we studied in network, there is some portion we are studying like arithmetic progression. We just given the name geometric progression, and harmonic progression is there. So those are, as you can think, as a part, but here is what we are going to study, that is also exactly the same, but we are going to study in a broader case. So in a as a definition, we will say the sequence is nothing but a kind of function. So let me write a function here. Suppose we have a function, this one, okay, x square plus 1. Okay, we have this function, and we want to study about we want to study its property, okay, on whole real number. Or even let me write the more complex thing, more complicated function. Let me like x square plus 1 upon x to the power 5 plus 9 plus x square plus, here is again I'm in addition, I'm writing here 5x upon 9x square plus 2x. So this is a, suppose this is a, we have a function, it is a complicated function. And suppose I want to study what is going to be the value of function fx at infinity. At infinity means end behavior. Now all of you know the end behavior. So what is going to be the end behavior of this function? End behavior means what is going to be the at infinity, means, as you know, in the polynomial, we know that if you are polynomial, end behavior means as what is going to be the output when you are substituting very large number. As x goes to infinity, it means we are trying to get the values when the x is very large. So what is going to be output? This is the end behavior, right? This is the mean of end behavior. We are, what is going to be in, give the output when we are trying to give here input, what is going to be output? Is it going to be positive infinite or negative infinite, or it is going to be some real number? So there we know that that's it. This sign, if you see that this sign is x goes to infinity, it means that you are trying to give the, as the input very large number, real number. So here is, suppose this is the problem we have, and we want to study about we want to study its property. So how we will study? So if we try to study on whole real number, it will be difficult. So can we do, or like now all of you know the subset also. So can we do like, here is, suppose you want to study some problem, okay, on this. Suppose we have a problem and I want to study the whole problem on this box or whatever in space. Suppose this is an space, or on a different way, or you can say I want to study that problem in the broader case. But if we study in a small portion, then we can extend that properties, or whatever we studied on this small set, we can extend that property in the broader form. So similarly, the sequence is actually, what is the sequence? If here we want
Your
to
voice
study
is
the
breaking,
property
sir.
on whole real number, let's do a study on the, okay, just let me check once. Okay. Is it better now?
No, sir,
Yes, sir.
it gets interrupted in between again and again.
Okay. So please let me know. I hope now is it it will be better. Okay.
Yes,
Please
sir.
let me know.
Yes, sir.
Okay.
Yes, sir.
Okay. So here, if we want to study about the whole real number, so it will be maybe difficult. It is a simple one, maybe you can study. But suppose we are in the very complex problem, and we want to study the property of the function on whole real number. So how we will study? So we can study the property on subset. On this, we know that natural number is subset of real number. Okay, natural number is subset of real number. So if we study like here, suppose this is the box is actually whole real number, and this is the smaller one, natural number. If we study the property of this function on this natural number, and we can extend the property to the whole real number. So this is one way actually to study the mathematics. Like whenever you will go in the higher mathematics, no, there you will generally see that we will, like, mathematician usually do the property or the problem. If you'll get, then they will start studying on a smaller set, and then try to expand the property on the whole space. So similarly here is, we'll study on the natural number and then try to expand that property on whole real number. So when we start studying this function on the natural number, so see here is x as a element of any real number, or x is belong to the natural number, real number. So similarly, just change the x as a n. Okay, if we change this x as a n, so this is going to be n means here you are going to use the natural number. The inputs here any real number, but now here is the input is going to be natural number. So in place of x, just rewrite n to the power 5 plus 9 plus n square, okay, plus 5n upon 9n square plus 2n plus 1. Now see that is it look like a right? It is looking like a sequence, no? So this is actually a sequence. Sequence is nothing but a function, but its domain is actually natural number. That's all. Sequence is not a difficult thing. Sequence is a function, but its domain is natural number. So suppose you are trying to find the limit of a sequence. Okay, you can think that is a function. You can still find the limit of function, limit of sequence on limit of that sequence, as you can think that limit. Sorry, if you suppose you want to find the limit of this sequence, so change this sequence in the function if you want. Just change that function in that sequence in the function and find the limit as x goes to infinity. Whatever the convincing way, you can do that. So sequence, why I'm saying if you are facing the difficulty with the sequence term, sequence word, so that's why I'm just making a familiar word that sequence is nothing but a function. It is not different. It is a function, but its domain is restricted. Its domain is natural number. It will never go beyond of that. Okay. And why also we needed that? Actually, studying on the irrational number, rational number, it will be difficult. While studying on the in compare of the counting number, you can easily study the property of function or 1, 2, 3, right? 5, 4, 7, 8, 9, 10, 11, whatever the on counting number. But it will be difficult to study on the root pi by 2. What is going to be the value? It will be always difficult to find exactly the value sometime. But if you study or if you find the value at 2, then it is easier to find the value. So that's why that this also in a different way we can say that why we started studying the sequence. The reason is we are actually trying to get the property on the counting number, which is natural number. Okay, all of you are getting this one, what is the sequence and why we are going to
Yes,
study,
sir.
or what is the purpose of studying the sequence. Okay,
So is this AGP?
sorry, so this arithmetic progression, no?
Arithmetic geometric progression,
Yeah,
sir, because
arithmetic
it
and
is like the
geometric.
same
So that is also
same.
see that it is a kind of, you can think that this is a function what f, this progression you can think as fn is equal to 2n, correct? So now see that if you substitute n is equal to 1, 2, 3, 4, 5, this is exactly the arithmetic progression, no?
Sir,
Yes.
9 will not come, sir.
Oh, sorry, here is 8 and 10, no? 10 will come, 10 and 12. I am trying to make 12, 14.
Yes,
Now it is
sir.
this sequence, no? Now this progression is actually exactly this sequence. So whatever we studied in 12 and 10, 12, 11 and 12, that is nothing but a sequence also exactly, but it's different way we are studying, but here is in the broader case.
Yes, in like 12th there was also A and capital N.
Excuse
N.
me,
So it
sir.
was like that.
Good evening, sir.
Yes, yes.
Sir, in this session, can we ask our doubt related to the graded assignment question 1 or 2?
So if you have graded assignment, please first see the solution. It is already uploaded from evening tomorrow, yesterday evening. So please see
Okay,
first the
sir.
solution.
Thank you, sir.
So sir, like AN plus B is like a function. We are
Yes.
treating it.
Yes, an plus b, so that arithmetic progression is kind of an plus b, which is a function, so which is a sequence. Okay, so now the notation is also changed. This f in bracket n is generally you can denote as the f suffix n. So if you are getting the difficulty, so this f suffix n is nothing but the f n, this in bracket. This is exactly one. And actually it is written in this format, so many people generally say that okay, it is a look like complicated, but it
Your
is
voice is
nothing but
breaking, sir.
okay, is it clear now?
Yes, sir. Now it is clear.
Okay, so sequence is nothing but a function. Now what we are going to study now, the convergent, divergent, or maybe limit of the
Sir.
sequence. Yes.
Sir, how to solve sequence which
Again,
has
sir,
its
your voice is
previous term
breaking.
in the series?
If it is written in the term of series.
No, sir. If it is an equal to an minus 1 plus an minus 2.
Sorry. Could you repeat plus?
An
Uh,
equal to an minus 1.
Oh, in this format it is written. Okay. An is equal to
Yes.
an minus 1 and
Plus an minus
minus
2.
Yeah. So
So, sir, how are we going to find them?
so in this case, what is the so generally very less chance to get such kind of problem. First, let me clear you. This is very less chance, and if it is you are getting if it is a such kind of thing, so you just assume that just assume that limit of an is equal to L. Okay, and now take the limit both side. Okay, if you take the limit both
Okay,
side.
sir.
So if you take both side limits, so limit will be separated with respect to this subtraction sign, which is here. Now limit is both side is separated. This limit will be the same here is L is equal to L minus L, or whatever the expression is written here. It is going to be 0, L is equal to. So by this way, you can exactly find the limit. Okay, and also if you get the value of L, you can say the sequence is convergent. If it is asking in the option wise. So till this time, it is if you'll use this formula, this will be okay for you. Okay.
Sir, in mock 6, there is a question 4th.
Yes, that is not that is if you see the solution, that is a very differently written. Okay, that is a very
Okay, sir.
different. Even if you use this one, it will not work. Actually, that whatever this recurrence, this is called recurrence. This recurrence is actually, if you see that solution, that is change in the different recurrence, and there it is the same. Whatever I am saying applied there. So that is a
Okay, sir.
much complicated problem, but I don't think will be asked again and again. Okay, that is actually
Okay, sir.
So we get confused when this limit concept and sequence concept get together.
yes.
Can we get some example on graph or real life? Like,
Sir, also please explain from just seeing the graph, how can we say that there is a limit exists or not, or to what
Yes, sir.
limit is proceeding?
Okay. Okay. So this is one way. Okay, that is in that we generally change with the different there in that problem. If you see the solution, that would be you will get that how it is solved. Okay. Now
Yes, sir.
let's back to the limit of sequence. So as you know, that limit is nothing but now, as you know, in the behavior of the sorry, why it is so in the behavior, in the polynomial, this is like this. So we know that how the function will go, like as x goes to infinity, what is going to be in the case of what is going to be the output, as in the behavior means it is going to be positive side or negative side. This is the mean of in the behavior we know. So as x goes to infinity, so you know that here means that you know what is going to be in the case of when it is going to be this side. This is the mean. So similarly, what is the limit? If you see the limit of sequence, let me write the notation here. Limit as n goes to infinity, n square upon, or even let me write n upon n square minus 1. Suppose this is the, and this is the notation limit. This is the sequence we have. What is going to be the limit of this sequence? This is the mean that you are trying to find the end behavior of this function. See, as this notation match with this one, whatever you studied in the polynomial, this is the same notation. And in place of x, it is n. And just now I said sequence is nothing but a function. So now, can you tell me what is going to be the end behavior of this function? This is a
Tending to
function
0.
tending to 0. As here in the polynomial case, you are always get the end behavior is going to be, or polynomial is going to be infinitive or positive infinitive or negative infinitive. Okay, but here it could be some real number. It could be, when you are trying to get the end behavior, it could be some real number. Why? The reason is, what is the reason? Now there you were in the polynomial. In the polynomial, that is a simple function, but here is you see that it is in the rational format. And so in it, so that is one way. So this is one thing, let me write here. So here is, if you have this function, no, suppose this is a sequence, or this sequence is fn, or differently I can write also f suffix n also. Okay, f suffix n or fn. This is the function. So what is the limit of this sequence is, as n goes to infinity, as you know, in the polynomial case, same, as n goes to infinity, is there any real number? Is there any real number that the whatever the input here is, it means you are trying to give the input here, infinite means very large number. Here you are trying to give input very large number. Is there any real number that, is there any real number exists around that you will get the output? If you are able to get exactly real number, then sequence is called convergent, and this real number is actually called limit. Okay, this is called actually limit. If you are unable to get, as the in the polynomial case, that infinite as here, this one, you know, in the polynomial case, it is going to be positive infinity or negative infinity. In that case, you will say the limit is not exist, as the in polynomial case. Suppose you are unable to get exactly the real number, so in that case you are not able to get the limit. So that you can say the limit is not exist for that sequence. For example, let me give here limit as n goes to infinity, n square upon n minus 1. N minus 1. Okay. So here is, in this case, the limit is going to be 0. Let me tell you the reason. You always need not to remember. The reason is, like, here is, if you want to find the limit as n goes to infinity 1 by n. So it means that in this function, you are trying to give the very large number in the denominator, and you are dividing 1 with the very large number. So see that if you are trying to divide this one way with the very large number, the output will be what? 0.00. Suppose you are dividing with a 1 lakh. So the output will be 0.00001, something very large. So that means you are, and whenever you are trying to do such lakh, 10 lakh, million, billion, trillion, whatever you are trying to do, the numbers will be actually, outputs will be close around the 0. The outputs will be around the 0. As here I was trying to tell you that the output will be around the 0. Here is, as here this one. So that's why you can say the limit of this one is going to be 0. Okay.
So if the limit is n behavior, then we can say, if in the polynomial function the n behavior is going towards the positive infinity, then
yeah,
can we
suppose
say,
suppose I'm let me give a polynomial x cube plus 5x square plus 2. Okay, suppose I have this polynomial. Let's change this polynomial in the sequence. So that means Pn. So now this is n cube plus 5n square plus 2. Now see that this is a sequence in the n format, which is look like a sequence, no? Pn you can write. Now it is the same behavior. What is going to be in the behavior for this polynomial? As x goes to infinity, px will go to infinity. How we will decide it? Using the degree and the coefficient, right? Using degree and the coefficient will decide it. So here is, we are not going to use this one. Here is one way you can think that if you substitute here very large number, now as n goes to infinity, as n goes to infinity and you are trying to know the end behavior. So as you are substitute here very large number, so n cube is going to be what? Also very large number. If you added with the also 5n square, also very large number. That means this is actually goes to infinity. These have the same property, just changed in the different way. Why I'm telling you, you need to think always.
So
This
for
means
when
that
x
you are
tends to
giving.
infinity, P of x tends to 2 only, right?
Sorry.
So when x tends to infinity, the P of x will have value 2 or infinity, sir?
Infinity, no. This is polynomial, no. I'm actually asking in the
Okay,
behavior, in the behavior of polynomial. Okay.
Sir, excuse me, sir.
Yeah.
How to know when n tends to infinity or n tends to 0? For some equations, it is.
No. So let me clear to you. It will be never such like n turns to 0. Okay. It will be never. For the sequence case. For the sequence case, it will never be n goes to 0. What it mean that n goes to 0? There is no mean. As n goes to 0. Okay. N goes to 0. If you are saying what it, there is no mean, because you can substitute in this here is n goes to 0 means you can substitute here and you will get the value. So there is no mean. We are actually trying to study when n is going to be very large. What is going to be the output? Is there any fixed number around that you are going to get the output? That is the meaning of the limit. That's why here the limit word came. Are we will we get a real number around that we are going to get a fixed number? Is there any real number where around that we are going to get the output? Okay.
And sir, n will start from the 1, sir, or 0? It will start from 1.
So
sequence.
here is for at least this calculus, as sir have said in the video lecture. So you will always think it is started from 1. Natural number is started from 1, and it is also is clearly will be specified in the in the when you start doing the maths section, you will get that in the intro. You will get that the natural number will not contain 0. Okay.
Sir, will the layman approach always work?
Layman approach. Layman approach means what?
Sir, this is layman approach, right? Because we are putting n equals infinity there.
Not
Like in a-
infinity here, not going to substitute here. So actually that's why I'm saying whenever you will see this sign, always make in mind that you are trying to give input very large number.
Yes,
and
sir,
many
like-
many large number.
Yeah,
and
sir.
once you give the very large number, what is going to be the output? In that case, are you getting very large number? So same sign will give that, okay, Pn is going to be, or same
Yes, sir,
sign you will
because
get.
in lecture week 3 lecture, sir said this method is layman approach.
Okay. So yeah, actually, so in sequence form, that's why I'm saying. So whenever the sequence is actually always thinking n goes to infinity, make your mind that you are trying to give the input very large number, and what is going to be the corresponding output? It is going to be very large number also, or it is going to be very some fixed number. So let me give another example. Okay. So suppose we have a
Excuse me,
sequence.
sir, can
Yes.
Yes.
Hmm,
Sir,
sure.
as you said, limit is n behavior. So in any case, in any graphical curve, if that curve is approaching towards a positive infinity, then can we say that limit of this function is approaching to infinity?
Yes, same as here. That's why I'm saying. That's why I took this one. No, this one. That's why I took this one, and this one is the same. Only the variable is changed here. Here is x, in place of x I just wrote n, but the same thing. But actually I'm trying to convey with the whatever just now said layman term. That means thinking to be the very large number and trying to give the input. Here you have decided using the coefficient and degree. But here we are actually try to convey with the, or try to understand with the large number term, that we are trying to give here very large number and try to get the what is going to be output. Okay. So this is the mean. Okay. So let me give an example of sequences. Suppose I have a sequence n square minus 1. Okay. Upon or here is n square minus 1, or let me write here the same with a different one, like root n plus, or here is root n plus root 2n. Yeah, okay, fine. This one, okay. Suppose you have this sequence. So what is going to be limit in this case?
Above 0.
As n goes to infinity, or here is plus sign, no? So let me make it here minus, and it will be more better. What is going to be limit in this case?
Minus 0 to infinity.
So here is 0 to infinity. No, one, either it could be 0, or it could be some real number, or it could be infinity. So if it is a real number, then you will say sequence is convergent. If it is infinity, then you will say the sequence is not convergent or divergent. If it is the limit is infinite. Limit is infinite means you are getting as n goes to infinity, fn is also approaching to infinity. So here is what is going to be the limit here. So to solve such problem, only we need to do some manipulation or some, that is called rationalization also. Let's do here rationalization means you need to multiply in numerator is root n plus root over 2n, and denominator with the root n plus root 2n. By this way if we do, so this is going to be what? This is a minus b kind of formula is
n
becoming
minus
here.
2n, sir.
Here is n minus 2n upon root n plus root 2n. So this is minus n upon root n plus root 2n. So we got fn is actually here, this one, minus n upon root n plus root 2n. So what is going to be limit in this case? Can you tell me what is going to be limit in this case?
Minus infinity to 0.
Minus infinity to 0 is
No,
not only
only
one thing.
in the
No?
minus infinity.
Why it will be minus infinity?
Sir, because there's a minus sign in front of that n.
So it may go to 0 also, right? No? How we
How,
are
sir?
sure that because of this minus, you are saying minus infinity? Can you tell me why it is going to be minus 1 or minus 2 or minus 0 or exactly 0? Can I say why cannot be 0?
Sir, because there's in place of n we will put very large number, so
Natural numbers, sir.
Infinity by infinity, sir. Minus.
So yeah, it is kind of minus infinity to infinity, you know. So what is going to be in that case? Like it is kind of you try to do some substitute, or you are going to say very large number. So here is also I'm substituting very large number. Here is also. So in that case, what is going to be
root n plus root 2n has to be greater than 0.
Root 2n yeah, it will be greater than 0, as n is a natural number, no? So always whatever the root you will get also will be the output will be always positive, no?
sir, but denominator will be positive infinity. It is not sure because we can cancel out taking root n common from the denominator, so it will be 3, and the numerator will be minus and root n.
Yeah, that's why I'm asking. If you take the root n as a common, okay. So if you take root n common, so here it will be 1 or root n common. So this is going to be 1 plus root 2. Okay? 1 plus root 2 you will get here. So now is here, if you finally, you know, now you did for the power, no, power of n, or maybe this is a to the power, or another way, right? If this is
root
1
2
and
by
this is
root n, right?
root 2 by root n. So yeah, finally if you do that, this is going to be minus n, okay, and this is 1 minus 1 by 2 upon to the power here is, and here is 1 plus root 2. So here is finally minus root n you will get.
Minus root n.
So this
By
is you will
root
get.
2 plus.
Now see
Yes,
that
sir.
this will not affect. You can do right. This is minus 1 upon 1 plus root 2, but here in multiplication is root n. Now could you think that if you substitute very large number, it is going to be still very large? Correct? Because you are just taking the root of it. So now if you say
Yes, sir.
that if you are going to substitute very large number, this is going to be very large. So that's why if you limit is going to be limit as n goes to infinity, fn is infinity, or and in as n goes to infinity, fn is also going to infinity. Okay. So
Sir,
this is the
means
mean here. Yeah.
minus
limit.
infinity.
Sorry.
Sir, Fn goes to minus infinity, I think.
Sorry. Here is minus infinity. I just forgot. Here is negative sign is there, so minus infinity. Minus infinity.
Sir, so in like in the quiz, so what will be the proper question? Like we have to find the limit, or we have to find the behavior of Fn or anything like that?
Yeah, generally it will be a limit. Behavior means, or in the if you see the many question is on the limit only, so limit will be there.
Excuse me, sir.
Yes.
So in the first line of the question, we could have done, that is, we could have taken root n as common, and then we could have written 1 minus root 2.
This one. Okay, you are mean to say if you take the root n as a common also, that would also work here. So if you take the root n as a common, so this is going to be 1 minus root 2, and the finally, that is also one way. We did this is one way also. This is correct one also.
So
if you do like this also.
So what will be the correct answer then? Infinity or minus infinity?
So now where it is going to be, infinity or minus infinity? Can you tell me?
So
by looking this number?
So in the long process, we found okay, so I got it, sir. 1 minus root 2 is a negative value. Okay, sir.
Yes, 1 minus 2 is going to be negative value. So still it will go to minus infinity.
Minus infinity. Thank you, sir.
Yeah.
Sir, it should be root 2
So by
root
this
n,
way
right?
is also one. Yeah. Sorry.
Sir, we took the root n common, so it should be root 2 by root n, right?
Root n, root. Sorry. What are you going to take common? Root n.
Yes, sir. From denominator we took root n common, so it will be root 2 by root n. Because is the root n included in the root, sir?
So no. Here is root 2. In the root 2 there is no n. Here is only.
Yes.
Okay, so let me move ahead. So this is the sequence about, and this is the limit. So whenever you are trying to get the limit, always think that we are going to substitute very large number, and corresponding that what is going to be the output. So similarly, now here is the limit of 1 by n is actually 0. Many times the main formula is generally you work as a 1 by n, and always think the n is going to be large. So 1 by n going to be very small. So 1 by n or 1 by n square or 1 by n cube all are actually approaching to 0, or 1 by n upon n to the power n. Still see that the same meaning is there. Very large to the power very large will get very large, still that is going to be 0. So again this limit is going to be 0, or even 1 upon factorial n. No, factorial n is actually, what is the factorial? And it is n into n minus 1 into n minus 2. If it is given, the formula will be written surely. Okay, if it is not, then there is no 2 cross 1. This is the mean still. So this factorial n is still, this is n is there always 1 by n of, still this will go also 0, or any other. If it is a 1 by some n expression is given, that means you are actually getting, you are giving very input very large number, and you are getting output also very large. So this is about the limit of sequences. Yes.
Sir, can you scroll a bit up?
Can you scroll up, sir, please?
Okay.
Sir, here where you wrote fn equal to minus n upon root n plus root 2n. Sir, here starting of the page only, sir.
This
Sir, there root
where is
2n, the n is not in root, no, sir.
Yeah. Root n common and 1 minus 1. N is not in root, yes.
Yes, sir. So it should be
So,
root
sir,
2
you
by
Just to
root n, right?
remember, and this is root n is out. Okay. So
sir,
So
when you
can
took
you
common
scroll
the
up,
forward
sir?
one root.
can
So
we
can you
move
scroll
ahead?
up a little bit?
Yeah, just see
Yes,
that
sir.
one
One
by
the root n is missing, sir.
Sorry, what is missing?
So in the denominator there should be
No, there
root
is
2
no
by
miss.
root n.
Root 2 by root n.
So last line of the page.
Root 2 by root n.
No, root 2 into root.
So, okay. No, this is correct. This is correct. Okay, please check with your side. It is, if you take root n common, so 1 will be here and root 2 will be remain. So this is correct. Okay, this is also correct. This is also fine. The power formula, 1 minus 1 by 2 is going to be there. So this is correct one. Okay.
So can you scroll up a little bit? I just want to see.
So why can we move ahead? I just here actually trying to explain you what is going to be large. Maybe if it is there is a error in the calculation, I hope you can understand that there is a error in calculation. I mean, I'm actually trying to convince you that what is going to be in the case of when it is in the n is there or root n is there or anything. Okay, if it is the error in the calculation, I think there is no error. If it is there, then certainly somebody have indicated that. But I think there is no error, but actually mean to convince that here is what is the mean, what is going to be limit, that's all. Okay, so no need to worry, no need to, if it is there is a error in numeric thing or minus plus or something is there. So let me move ahead because we sequence also, and this is the, I think that's all in the limit form. Now let's move about the limit of function. Okay, so limit of function now. So as here limit.
Dear, can you briefly tell what was there in limit of sequences? Sir? Because I was unable to listen because of another work.
No, sir. See, if you are did an order work, we just now finished. No, limit of sequences. What is the limit of sequence?
All these sessions are recorded. I think you can go back to the
Yeah,
recorded
go back
session.
and just listen that. If you are still again do for you, then
Okay, sir.
yeah, what I will do the head thing then now. See, we did spend more time here. So one by one, if you go back and watch on YouTube, that would be good. Okay. So limit of function. Now let's talk about the limit of function. So same in the behavior
But
term,
could you
we
see
will
till
listen
this
here
one,
also.
what topics have you discussed, sir? That alone would be fine. Just the topic.
Sorry.
So could you just say which topics have you discussed till now, sir? That alone would be
In
fine.
sequence only we did.
Okay.
Only about the trigonometry function and the sequence. Now we'll going
Okay,
to
sir.
discuss limit of function and then limit of function and indeterminate form, L'Hopital rule, and the continuity. Okay. So limit of function. So let me give an example by using the example we can discuss. Suppose I am giving a minus 1 upon x square minus 1. Suppose this is the function I have. Okay. Now, if we substitute 1 here, what is going to be the output?
Indefinite form, sir.
0 by 0 form, right? It is not giving the exact value. But can we think that if we give the input in this function around 1, suppose here is 1, okay, here is 0, here is 1, and if we try to give input very near to which is 1, either this way or this way, or this way or this way, okay, if we try to give input, what is going to be the output? What is going to be the output? Is there any number? Is there any number around that you are going to get the outputs? If you are trying to give input around the 1, which is either it could be 0.009 or sorry 0.99998 or whatever the number, real number, which is very close to 1. Okay, I am trying to give input in that. Okay, so what is going to be output? Is there any real number around that you will get output, or it will go infinity? Means it is not the exact value. As here we are unable to decide what is going to be output in this
So
format.
from
In this
left hand
exact
side,
format,
it will be negative infinity, and from right hand side, it will be positive infinity.
no, it will not. So that's why I'm actually trying to tell you, it will not
Sir,
go.
I have a doubt here.
Will tend to 0.
Sir,
Yeah.
sir, like if the limit x tends to 1, then only it will be there as 0/0, no, sir?
So yeah, if as x tend to 1, it is a kind of becoming a 0/0 form. So why it is 0/0 form in exact function? If you mean to say, if you are trying to substitute here exactly 1 in this function, you are unable to get value. You are unable to get exact value what is going to be output. But if you are trying to substitute here, suppose less than number, you are trying to give input in this function, what is going to be output? Can you tell me what is going to be output? We don't know, but can we approximate that value? Can we tell that it is going to be around some real number? Can we approximate that? Okay, if you substitute here 0.9999 in this function, it will give actually around the 1/2 value. Means actually I'm trying to will get the output. So that is the limit here. That is the word limit. We are actually trying to get values whenever you are trying to give input here around the 1. We are actually get the values around 1/2. We'll see that how it is coming. Okay. So this
By L
is the
hospital,
mean here
2 times
limit.
differentiation.
So yeah, L'Hopital will do, but L'Hopital rule will help. Yeah, that's the when that we'll discuss later. But I am actually telling you how it is coming, or what is the mean of the limit. What is the meaning of limit? Okay. So as x goes to 1, the fx. Here is the meaning are. Now here you can make in your mind that you are trying to give the input around the 1, not exactly 1, around the 1. Here is as x goes to in 1, it means that you are trying to give the input around 1. Okay. But there, in the limit case, that is a different, totally, here is any real number. So as here n goes to infinity, we are trying to get the end behavior of the function. But here what we are doing, here we are trying to give input some real number, and we are trying to get what is going to be the output. Is that around some real number you are getting, or you are getting infinite? Okay. So here is, this means that you are trying to gain input around 1. So what is going to be around values? Is it going to be around 1/2, or it is around to 5/2 or something, anything, or it is going to be infinity? So if it is, suppose here it is going to be infinity, then we will say limit is not exist. If it is going to be a real number, then you will say the limit is exist. If it is going to be some real number, it is, if you are getting the outputs around some exact real number, then you will say the limit exists and limit is 1/2. If it is not, then you will say limit is not exist. So how will solve now? So this problem is actually now.
So if limit tends to infinity, the limit does not exist.
We'll see that how. If limit tends to infinity, we'll say limit is not exist. Okay. Or other way also we'll say, when we'll say there is another word or different way also can tell that when the limit is not exist. Okay. We'll see later. Here itself now. Let me finish it. So here is again you can write limit as x goes to infinite, x goes to 1. Okay. So this we have function x minus 1 upon x square plus 1. So let's do some here calculation, or let's do some arrangement, or let's solve this expression. This is 1 minus x minus 1. This is x square minus 1. So this is x minus 1 into x plus 1. Now cancel out. This is going to be x plus 1. So this function is actually can be written as this exact function can be written as also x plus 1. Now if you see that if you give the input around 1, it will actually approach to 1 by 2. Even you can substitute here 1 exactly, you will get the 1 by 2. Okay, so this is the meaning is actually happening, that you are at exactly 1, you are unable to get the value, but whenever you are trying to give input around 1, it is actually value is coming around 1 by 2. This is the mean of limit. This is the meaning of limit.
So here we are getting real number. It means that function
So
is
here you are getting a
finite.
real number, exactly real numbers. That's why the limit is exists now. Now
It
let me
means
tell
that
you
the function is not going to the infinity. It has some real value, and it has a finite.
limit. Yeah, finite real number.
Oh, okay. So,
now let me tell you the left limit and right limit. Okay. Left limit is right, and right limit is nothing but the small. We have to see a very careful thing, that if you the left side, only the left side. Okay. If you are trying to give input in this function from the left hand side, is there any value that the output is actually coming that exact number? So that is called left limit. And suppose you are trying to give the input from the right side, only the whatever the input which is greater than 1. Okay, greater than 1 values you are trying to give the input. Is there any another value or exactly this one? Okay, it could, there is a possibility that it could be another value also. So in that case, if it is two different values, suppose left limit, in the left limit case you are getting some different value, and the right limit, in the right limit case you are getting some different value. In that case also we will say the limit is not exist. Okay, in that case also we will say the limit is not exist. If it is the same in the both cases, here it is actually the same point. If it is coming from the left and right at the same around 1 by 2 you are getting, then you will say limit is exist. If it is from the left side you are getting different, and from right side you are getting different, then you will say limit is also not exist. Okay, this is one important thing. So this is one we have. Okay, limit is done. Limit is, so for example, let me tell you the left limit and right limit is, suppose fx is I'm defining as
sir.
Yes.
Sir, if the left limit is equal to right limit, then the function will be called as continuous also, no, sir?
No. Left limit equal to right hand limit, and it should equal to value of the function also. Not only the left, right, also should equal to value of the function.
Okay, sir. But if the left limit is equal to the right limit, then the function will be called as continuous?
No, not necessary.
Not necessary.
So let me
Under
give an
some
example.
condition. Okay,
So
sir.
let me give an example. It will be using that, it will be more clear to you. So suppose suppose we have a function when suppose this is x square plus 1 when x is less than 0. Okay, and 2 when x is exactly equal to 0, and x square plus 5 when x is greater than 0. So this, see that this function is stepwise, and no need to worry here. This means that whenever the value is lesser than 0, your function will work as here. Means you will give the input in this here, and if it is exactly 0, then your function value is 2, and if it is greater than 0, 2, 3, 5, anything, then you will give the value here and get the output. So this is the meaning of function, and this is called the stepwise function. Okay, this is in the break form, in breaked form, or stepwise function you can say. Now let's see that here what is happening. I'm trying to find the left limit. Okay, left limit. So left limit is as x goes to 0. Left limit notation is or approaching to 0 from the left side means like this, 0 to the power minus sign. This is the mean of approaching to 0 from the left. Okay, and the function, this function. So what is going to be the left limit here? Means here in this, here let me draw the graph. Here is 0. Okay, suppose the graph of this one is what? Suppose this is y-axis, this is x-axis, this is y-axis. So in this portion, the graph is x square minus 1. So suppose the graph will be shifted to right side. So like this, the graph. Okay, at 0, the value will be minus 1. And at 2, the value is 2 here. And at x square plus 5 is going to be like this. The graph may be like this. Okay. So see that if it is less than 0 means the graph is like this. So less than 0 means that this function will work. So if you are approaching to 0 from this left side, this side, you are trying to give input from this side, you are getting the output, see this one. So what is going to be output here? So limit, what is going to be the limit from the left hand side?
That's what.
Minus 1.
Minus 1.
Minus 1. What is going to be the right limit? Right limit is actually approaching. The notation is right hand limit is 0 to the power plus sign and fx is here. So what is going to be in that case? That means you are trying to give input from positive side. So what is the output? Here is we have output. This is the output we have. So this function will work. So what is going to be output exactly as you are approaching to 0? This is here. Here is open sign will circle will be, not bullet point. Here means circle means you are not get the exact value, but you are, as you are approaching to 0, the value is actually coming around the 5. So limit is going to be 5. So now see that the left limit is not equal to right limit. So in that case, you can say limit x going to 0. Now there is no upper sign is positive or negative fx. Now it means that limit at 0 is not exist, as the left limit is not equal to the right limit. Okay. And suppose I'm making here. Now let me the same with the different function. So limit is not exist in this case. Suppose now writing a function fx is equal to x square minus 1 when x is less than 0, minus 1 or let's say 2, or let's say 2 this one, which is when x is exactly equal to 0. Okay. And x square or x square minus 2x minus when x is greater than 0. Okay, suppose we have this function. Okay, suppose we have this function. So what is the left limit of fx?
Minus 1.
Minus 1.
Minus 1. What is the right limit?
Minus 1.
So
Minus 1 again, as just need to substitute here, you will get minus 1. Here is for left limit is going to be, if you substitute here. So now see that left limit equal to right limit, right? That means you can say as x approaching to 0. Now there is no sign, means here exactly meaning you are approaching to from left and right. So as you are approaching to 0 from left and right means your limit as x goes to 0 is minus 1. Correct? Because left and right are the same. So limit at 0 of the function is minus 1. But see exact value at 0. Here is approaching to 0 is minus 1. But at exact 0, what is the value? 2. Correct? At exact 0, it is 2. So in this case, that this limit value is not equal to the function value, right? At 0, the function is 2, but here is the not function value. So this is called the function is not continuous. It is not continuous. Okay.
Not continuous, but limit exists.
Limit exists, but not continuous. Okay.
Yes, sir.
Okay. So this is the limit about the limit of the function and okay.
So it means the
Now,
end part of the curve is stopping somewhere. That
yes. At the exactly 0, if you see the graph of it is kind of the graph of this function is actually this. At 0, this value is exactly 2, and then the right side the value is actually the polynomial that the same will be as here this side -1 as getting us. This is again the circle value. Here is circle, and it will be like this parabola or maybe sharper. I don't know how it will be, but here is that there is a break is actually happening. If you see the graph, we try to draw the graph. You can now easily draw, because left side you need to draw with the kind of x square -1. Right side the graph will be x square x2x plus 1. What is that? -2x plus -2x -1. And at 0 the value is here. Now now continuity part, what is the continuity when you are studying about the polynomial or anything, that sir were saying that it is a continuous, there is no break, but here is a break, no? So that's why in another way we verified with the that mathematically or algebraic way, but here we are also looking through geometrically that the graph, if you see the graph at 2, here is value, and this side or this side the graph is like this. So that's why this function is not continuous, but yeah, limit is exists. See that approaching from this side or this side, approaching to 0 from this side or this side, the values is actually around exactly at -1. So limit is exist, but the function value is not the same as the limit value. So that's why this function is not continuous, but the limit is exist at 0. Okay.
So here we see the end part of the curve is stopping somewhere at that particular point where is the function is discontinuous.
No, and end part is now it is continuous. No, how the graph is like this, or we don't know. End part is like as x goes to infinity or minus infinity. In that case, it will work as as x goes to infinity, this will work. Sorry, as x goes to minus infinity, this function will work. As x goes to positive infinity, this function will work. Okay.
But at that particular point, sir, where the discontinuity is happening, that is also the end part of the curve at the another end.
End part means what? End part means what you are saying? End part means there is no end part.
Actually, sir, I was thinking about that as you said, no, limit is end behavior. So at that
so
point,
here is the end behavior for as always think for as n or x goes to infinity, but here is now we are in between. Here is not end behavior happening. Here is actually end behavior is actually, I want to tell you that what is going to be the output around that. Now here is the same thing, but here is not end behavior. Here is exactly at 0 we are trying to find. So end behavior is kind of what you are doing. You are giving the very large number input. Here is as x goes to infinity means you are trying to input around the 0. Okay. So in the end behavior case, you can think for only as x goes to infinity. If you are confusing with that, whenever you have end behavior, as that means your x goes to infinity. That case you will say, if it is x goes to some real number, then that is not end behavior. That is you are trying to give input around some real number and try to get some what is going to be the output. Is that any around that number you are again getting the output or some infinity, or we don't know. Actually trying to investigate that.
Okay, sir.
Okay. So the function is discontinuous and non-differentiable at x equals to 2, right?
at x is equal to 0, not 2, at 0. This is 0. We are actually investigating as 0.
So one more question, sir. Sir, as you said, sequence is a function because lot of points in that graphical curve is forming that function in some order, one after one lot of points. That that curve what we are getting, it is formed by lot of infinite number of points, one after one. That is a sequence. That's why we call it a sequence.
Yes, yes. Yeah.
Oh, okay, sir. Okay, thank you.
Okay, so let's move now. The limit is done. We have now, yeah, some limit is a limit at infinity we have also. So limit at infinity we have, limit at infinity. What it means that we are trying to get the limit of the function when as x goes to infinity. So let me take a function fx is equal to x square minus or maybe x square plus 3x plus 5 upon x cube plus 3x square plus 2x plus 1. So here is limit at infinity means now here is actually we are trying to get the end behavior. So as x goes to infinity, what is or simply limit, what is the limit value as x goes to infinity fx? What is going to be this value? So here it means again, here is the meaning of end behavior. We are trying to get the end behavior of the function when as, or in another way, as x goes to infinity, what is going to be the output? Is there any real number or still this fx is also go to infinity? So what is that? How we'll solve this problem?
So you have to factorize this, sir. Then find out.
No, factorizing is not work. Only there is a simple way we can do.
That
To
taking
take common out,
common factor.
Take x square
x
common.
square common. This is 1 plus 3x, sorry, 3 by x, and this is 5 by x square upon. Now you can take x square common or x cube common. Okay, so this is going to be 1 plus 3 by x plus 2 by x square plus 1 by x cube. Right, now you can cancel out. So this is going to be 1 by x. Now as x goes to infinity, this again the same meaning you can think as the sequence form. This is going to be as you are, as x goes to infinity means you are trying to give input very large number. So what is going to be when divide the very large number? You divide 3 with very large number. It is going to be 0. This is going to be 0. This is going to be 0. This is 0. This is 0. And this is also finally this 1 by x will go to 0. So it is what is happening 0 time 1 upon 1 kind of thing, right? So this is finally 0. So this is called the limit at 0. Sorry, limit at infinity. Okay, this is called the limit at infinity. We'll have seen in the last lecture, I think so. Okay, of this week 7. Now we done with the continuity also. I'm not going to spend much time there on continuity because continuity is nothing but the exact value should equal to the limit value. Now let's move on to the differentiability. Okay, differentiability. So the differentiability is actually generated, or you know, when you are all of you have studied the real line. Okay, and if you have 2 points here, suppose this is x1 y1 and this is x2 y2. Okay, suppose you are in 2 points. So slope of this line is what? Is generally y2 minus y1 upon x2 minus x1. By this way, this is the slope of a line. Okay. This is the theta m is m or tan theta is exactly this one. Okay. So this is the slope of a line. But suppose in place of this line, if we are studying about the curve, see here is this line and we got the slope. But when we are in the curve form. So what is going to be, suppose here we are, okay, and there is another point here, okay. So here is what is going to be the slope of this curve, how we will find the slope of this curve. So another way to find the slope of a curve, like at here, what is going to be slope of the curve? Here is, see, the slope, see, each time, see, this is the straight line and always the slope is constant, no, always the exact slope. But here, see the curve, it is always convert, like it is always changing by, sometime is this one, this one, this one, this one, some, it is always varying here. So how will get the exact, so here is, this is a constant, no, if you try to get the slope here of this line, you will say that this is always, slope is constant, you will say that the slope of the line is exactly same as here. But here in the case of curve or a function, this is always converting, like always changing, so it is a difficult to find the slope here. So that's why the slope will means here, the slope of the function means the slope of the line of, slope of that line, slope of that line which is actually touches at that point to the curve. So here is the slope of the curve, means we are actually trying to find the slope of that line which is touching exactly at that point. What is going to be the slope of this line now? This is the mean now, slope of this curve at this point. But here about the line, we are actually studying with the saying to be that this is the fixed slope. But here is because of the varying thing of the slope, okay, because of this varying thing of the curve. So whenever we talk about what is the slope of here of the function, so what we will do, we'll try to draw a graph, okay, sorry, we'll try to draw a line which touches the curve here, and we'll try to find the slope of this line. What is the slope of this touching curve, this touching line? So this is the mean of slope of the curve. So now the differentiability come in the picture, that how we will calculate the slope of the curve. Okay. So to calculate the slope of this curve, let me make another function, another graph. So to calculate the curve, no, the same way as here we did, by this formula we calculated the slope of the line. Similarly, here we also try to calculate. So suppose this is A here and this is B. Okay. Okay. And I want to try to find the slope of the curve at here. Okay. So what you can do, you will get the value f of A, here is f of B. So same, use this the same thing. So this is upon B minus A, or differently also, or you can say I want to find the slope of the function here at B. So by this way, the same formula is here. This point is A time, sorry, A f of A, and this is B f of B. With the same formula, I just wrote this one. Okay. Now, if you are, this A is actually, can we say, approaching to 1. Now think that is actually trying to converge and approaching to Earth. So can we do like this? As X is approaching to, or sorry, here is different way. Can we say that here? Here is, as you can say, A is approaching to B. A is approaching to B, f of B minus f of A upon B minus A. Or maybe you are looking at different definition, so that's why let me remove this one. Okay, maybe you, all of you, whatever you have gone through lecture, maybe you will get confused, so let me raise it by different way. Let me tell you that you want to find the slope of the curve at A. Suppose this is A and this is, let me write here, a small distance here, which is A plus H. That would be better. Now it will be better. A, so this is the function value is going to be f of A plus H. So suppose this is H. Okay? Now, and we want to find the slope of the curve at A. So now how we'll find? Again the same, f of A plus H minus f of A upon A plus H that here y2 minus y1, okay, f of a minus a, or now this a will be cancel out, so this is going to be f of a plus h is here, minus f of a upon h. So this is the we have. So see that here is h. So this is h we have, so it is divided by h. So see what is happening. This distance divided by this distance. So if we say that as h goes to 0 means I am actually trying to very close to a, and this distance and dividing that, and we are actually trying to make it very close to a. So how we'll make it that? So we can say that as h goes to 0. So as h goes to 0, what is going to be the limit of this? So this is called the differentiability actually. So actually if this limit is exists, then you can say the function is differentiable at that point, and whatever the limit you will get, that is the slope of that line which touches the curve at a. Okay, this is theta. The slope of that line which touches the curve at a. So all of you are getting what is the meaning or what is the differentiability meaning. So differentiability is actually we are trying to get the slope of the curve, okay, in the as you case of the line. But how we'll get that? As in the curve it is always varying. So in the case of exact point we are actually trying to find the slope, and this is the formula. So this limit value is actually give the slope value at a, means the slope of the curve at a, means the line which touches the curve at a, that is the meaning. Okay. So if limit is exists, then you will say the function is differentiable. If it is not, then you will say the function is not differentiable. Okay. Is it clear now?
Yes, sir.
Okay. Now let's solve some problem, and we'll see that in the you have also
So
gone through the
the method
tangent.
is the limit only, right?
Sorry.
Equal 12. For differentiability, could you just explain the criteria again? Limit h tends to 0 for a plus h minus f of a by h must be
If
equal.
it is this limit is exist, okay. If this limit is exist, then you will say the function is differentiable at that point.
Okay, so if the question they've given some function and they give some options like continuity, differentiability, and so on, how do we check for differentiable? So that's where I'm struggling.
So if you suppose, so for example, let me take that if you have function this fx is equal to mod x, I'm saying, okay. If it is a mod x is there, okay. If mod x is there, so let's check here the limit, continuity, and differentiability all, okay, for mod x, or let me write the mod x minus 1, okay. And we want to try to check is limit exist at 1, is function fx is continuous at 1, is function fx is differentiable at 1. These three questions we will try to investigate for this function. Okay. So we have function fx is equal to mod x minus 1. Okay. So if you write this function in stepwise, can you tell me how we'll write?
X minus x minus 1 when x is less than 1.
If x is less than 1, in that case, what is going to be? This one, right? Minus x to the minus 1. And as x going to be greater than or equal to 1, in that case, x minus 1, right? This is the meaning of the mod. Okay. How it came, it is just a way to think. This is this mod is actually give the positive value or absolute value also called. So if suppose x is less than 1, that means you will get the negative value here. So how I want to make it positive means make it here minus, and then it will become a positive. If x is greater than 1 means this one is always positive, and mod is there, mod purposely written there for get the positive value, so there is no change. That's why exact the same, x minus 1. Okay, now I want to find the limit as x approaching to 1. So how we'll find? So we'll try to find the using the left hand limit and right hand limit. So left hand limit is again limit as x approaching to minus n 1 to the power. This is the mean of left sign. This is what? Minus. What is going to be limit here?
So 0.
What? This is going to be 0. Again, the right limit?
0.
0.
Is 0.
This is 0. That means, can we say that limit is exist at 1 for this function? Right? Left limit is equal to right limit.
Yes,
So
sir.
limit
F of x
course.
is equal to 0. F of 1 is equal to also 0.
Yeah. So limit is actually 1 here. Sorry, limit is exist here. What is the function value at 0? Sorry, at 1? 0. Right?
0.
So function value also 0 and limit value is also same. So that means limit is exist here and function, this tells you function is continuous. Two things we have verified. Now let's do for the differentiability. Okay, so how we'll check again? We want to check the differentiability of the function at 1. Okay, so what is the process? So let's write exactly the limit definition itself to check the differentiability. Limit h approaching to 0 f of 1. So what is the definition we have first? Limit differentiability at a. To check the differentiability at a of the function fx is limit h goes to 0 f of a plus h minus f of a upon h, right?
Yes.
This is the definition. We have to check the differentiability. Always use this definition. This is the definition. So here is a is our 1. So f of 1 plus h minus f of 1.
H tends to 0 or h tends to 1?
So h will be tending to 0 always. In the definition, see carefully the definition. In the definition is always h tending to 0. Okay. So see the
Sir?
definition. And now this
Sir?
0 is actually
Sir, how it would be
Yes.
continuous? Like if f of 0 is equal to the same value as left limit and the right limit, then only it will be continuous, no, sir?
Yes, then it is a continuous. Only that way I am saying it is continuous.
That you put f of 1 is equal to 0 and underlined it as continuous. So
Yes. If, I substituted here 1 here and I actually get that the function value is 0.
Sir, is it
f of 0 wouldn't be there as minus 1, sir?
Sorry.
Sir, f of 0 wouldn't it be there as minus 1?
Yeah, f function value at 0 is minus 1, but we don't care about, no? The problem is at where? For this function, the problem is where? Is it problem at 0 or is it problem at 1? For this mod function?
But at f0, sir, it is discontinuous, no, sir?
No, why it is at 0 it is discontinuous?
Because at 0, HL equal to RHL, but function value is not equal to same.
No, why? What is going to be limit of the function at 0? At 0, what is the limit? The function we have like this one, no? Less than the value is less than 1, the function we have like this. So is this function is, what is the limit will exactly the function value also, because our function is now when x is less than 1, the function we have like this, exactly this one. So why the issue is, it is we have like this one, this is mod x minus 1. And if you want to find the limit at 0 as x approaching to 0, the function we have, this is 0 is less than 1. So function we will behave like this. That means minus 0 minus 1, which is 1. What is going to be the right limit? Or at 0, the limit is 1, right? And for what is the function value at 0? Function value at 0? function value at 0 is also 1. So function is nicely behaving around the 0, no? The problem is at 1 only. When x
Okay,
is
sir.
less than 1, then the function behaving like this. If x is greater than 1, the function behaving like this. And if it is for except that, the function nicely is behaving. If it is less than the value is input you are giving less than 1, the function behave like this always. If it is x is greater than 1, function is behave like this always. Only the problem is at 1. Okay, not at 0.
So
Problem. That's why
continuity is also important.
intentionally that's why I took in starting I took mod x, but why I took mod of -1, because I actually want to see the problem at 1, not at 0. So intentionally that's why I took this function. Otherwise in starting I took mod x because this creates problem at 0 only, but this creates problem at 1. Okay, now is it clear?
Yes, sir.
Yes, sir.
Okay, so whenever we are trying to check differentiability, always use this definition, and if limit is exist, then we'll say then we'll say the function is differentiable. So this h is approaching to 0, no? This h is approaching to 0 is both side telling. So we have to find whenever this is there, now we have this limit want to evaluate. So this is braked. This limit is braked now. This is left limit and right hand limit, or left and right, whatever. So this limit is braked now. So now the left limit, for this limit you have to find the left limit. So limit h here, h goes to 0 minus, you can use the same and limit h goes to 0 positive on h. Okay, so here is okay, this is we have. So let's find here the limit here for this function mod x. Fx is mod of x minus 1. So limit h tending to 0, left hand side. This is 1 plus is what? 1 plus h. This is 1 plus h minus 1. So here is, just need to note that here is h approaching to 0 from negative side, means the h value is actually negative value. H value is negative value. So you can do it here exactly the same here, or just a minute. The negative value you are substituting here is 0 approaching to 0 from left hand side is, and h is actually negative value. So okay, so this is 1 plus h mod minus 1 minus at 1 value is, at 1 the value is 0 upon now h. Okay, so this limit h approaching to 0 negative, this will be cancelled out. This is mod h upon h. This is we have
Minus, right, sir? 1 minus h.
So can you just explain how did we substitute mod of h 1 plus h minus 1?
now
This
h is negative, no? This h is negative. So what is going to be this value? This is what? What is this?
Minus 1.
Am I audible right now?
Yes, sir.
Yes.
Yes, sir.
Okay,
Sir, can you
I
just explain
lost.
how for the
Screen is
left
not
hand
visible.
derivative f of 1 plus h becomes mod of 1 plus h minus 1?
So where I from till which place you are discussing, like here or which place, or here? This one is clear? No?
So the left hand
Where
side.
my connection
Yes,
have
sir, that one only. F of 1 plus h, how did we get it as mod of 1 plus h minus 1? That is mod.
So this is just substituted. I am just substituting here. F of 1 plus h is what? In place of x, so in place of x, you will substitute here 1 plus h, no? Our function is this one.
Yes,
I just
sir.
substituted here, which is in mod. So mod in this one, minus function value at 1 is 0, okay, upon h, right? Now finally you got minus h, sorry, mod value of h upon h. So what will be this one? What is this one? What is the mod h? When h you are going to 0 from negative side, means
Sir,
when
minus
h
1.
is negative
Minus
value,
1.
this is going to be minus h, right? When h is negative, then this is going to be minus h. So this means, as this tells you h, as you are approaching to 0 from negative side, that means this mod is actually minus h. So you can say that limit h tending to 0 negative, this is minus h upon h. So this is going to be cancel out. This is going to be minus 1. Now back to here, right side. So again, limit h approaching to 0 positive. Again, the 1 plus h, you just need to substitute here in place of x. 1 plus h, this is 1 plus h minus 1 mod again. Minus function value at 1 is 0 upon h. So limit h tending to 0. This 1 and 1 cancel out. Mod h upon h. Now you are approaching, your value of h is, you are going to 0 from positive side. So this mod is going to be what? Positive, right? This mod is going to be, this mod as a mod h is actually h when minus h when h is less than 0, h when h is greater or equal to 0. Okay, this is the mod, or mod, as the mod, same mod is there. So this is going to be exactly h by h, limit h tending to 0 positive, h by h, which is 1. Limit is 1. Now see that left limit. So let me know if first, is it clear or not? This one and this one. This one.
Yes, sir. It is.
Yes, sir.
Okay. So now see that this is the left limit, and this is the left limit, and this is the right limit. For this limit, one by one, we calculated left limit and right limit and got that left limit is minus 1 and right limit is 1. And so minus 1 is not equal to 1. So that means this limit is not exist. This limit is not exist. What it mean that the function is not differentiable at 1. Okay.
Yes, sir.
Now this is the algebraic definition of differentiability. Says now in geometry, if you, let me tell you the differentiability. If suppose like this, the graph is there. Suppose the graph is like this, or the graph is like this. It is again, let's say this is a sharp corner again, and then start again. So if there is a break at here, if there is a break, then at here, at x is equal to, let's say this is a, so at a the function is again not differentiable in geometrically. Directly you can say if you check the limit format of this one, this is left limit is not equal to right limit will come.
Continuity
And also
is
not
important, sir, for
continuous.
differentiability.
It is not continuous even. This function is not continuous. There is a break. But see that this function is actually continuous but not differentiable where the sharp corner is there. Like these 2 points. At this point, this is the sharp corner is there. If there is a sharp corner, but it is continuous. So the function is continuous. There is no break, jump is there. The function is continuous. This is continuous, but not differentiable. This function is not differential but continuous. Here is also, you can say the left limit is not equal to right limit also. Left limit is not equal to right limit also. And the function is not continuous also, not differentiable also. But here is left limit equal to right limit means limit is exist at every point. Function is continuous, but the problem with the differentiability, not differentiable.
Sir, how you said it's not differentiable over here by seeing the graph itself?
Not differentiable is as if you see that graph of this mod minus this one. Let me tell you now the graph. Here is suppose 1. So what is going to be the graph of mod of minus is mod of x minus 1 is going to be this one. This is the graph of mod of minus 1, mod of x minus 1. So here is actually happening the sharp corner. And if you see the algebraically, the reason is actually happening this one, the left derivative. This is called left derivative for this one also. Left limit of this limit is actually called left derivative, and this is the right derivative. This right limit is also called the right derivative. So left derivative is actually coming -1 and right derivative is coming 1. The reason is also, as if you draw the graph of mod x, there is a sharp corner is actually happening. So at 1 it is continuous, limit is exist, but the differentiability is not happening. Okay.
Yes, I got it.
So similarly, you can say whenever the sharp corner is there, at that point the function is not going to be differentiable.
So smooth curve and continuous.
Now the function is not differentiable. Suppose here is the suppose the function is not differentiable, and in starting I said no. In starting I said what? That why we are trying to get the differentiability? The reason is we are trying to get the limit is actually give the slope of the tangent. So if suppose the function is not differentiable at here, can we get the slope of the curve at this one? No, right? So there is no tangent. So actually at 1 there is no tangent, because just now said this limit or differentiability limit. So whatever the differentiable definition, this limit is actually give the slope of that curve. What do you mean by that? Slope of the curve means slope of that line which touches the curve at that point, and that line is actually called the tangent at that point. If you are unable to get this limit, then how could be the slope of the function exist, or a different way, how could be the tangent line will exist? There is no tangent line at where the function is not differentiable. So as here, at the sharp corner, there is no tangent line will happen. Everywhere the tangent line is there, the same line, but at 1 the tangent is not exist. The reason is the function is not differentiable in other way. So simply in other way, if there is a problem that somebody says that at this point the function the tangent is not exist, then you can say the function is not differentiable also at that point. Okay. So this is the one thing, and if the function is differentiable, function is differentiable, this means that function is continuous. Okay, function is continuous. If function is continuous means limit is exist, and function and equal to the function value, Okay. If function is if function is continuous, this doesn't mean that function is differentiable. It doesn't mean. Okay, it may not be differentiable. It could be differentiable. It may not be also. Okay, this is one thing. And if another way you can say, if tangent at a point exists, then function is differentiable. Then function is differentiable at that point. And vice versa also. If function is differentiable, then tangent is exist also. Okay. Is it clear now?
Yes, sir.
Yes, no. Okay,
Function
this
is
is
not yes, then can we infer
I
that?
want to make a note.
Continuity is always
Sorry,
important for
function is
differentiability.
So if function is not continuous at any so
your voice is breaking. Function is not continuous at
yeah, if function is not continuous at any point, then
Hmm.
can we infer that function is also not differentiable at that point?
At any point. Yes, the function is not differentiable at any point. If you are saying any point.
Yeah,
If
yeah.
function is not continuous at any point, then function is not differentiable also at any point.
Yeah. Can we infer this?
Yes.
Okay.
So differentiability actually needed. So that's why if the function is differentiable, the continuity part will happen. But this is not in the reverse part. If the function is continuous, function may or may not differentiable. It may differentiable, it may not also. Okay.
Yes, sir.
Okay. Now let's back toward the indeterminate form. That is a very small and that is not a big thing. Indeterminate form is, suppose your function is kind of f by gx form, and when you started to find the limit at some a, okay, when you started finding limit at some a, it, so what is that? If you substitute a, it is becoming a 0 by 0 form, or positive infinity by positive infinity, or negative infinity by negative infinity. Okay, this three kind of thing is happening. Then you will say this function, the whole function fx by gx is actually indeterminate form, and to find this limit is exactly the limit to finding. Just derivate separately f prime and g prime separately, and then find the limit at there. Let me give another example. Let me give an example here. So what is going to be limit? Just derivative of the function and then find the limit. So let me write the derivatives of function first, then it would be good. And I request you to remember this, because you may get some problem on derivative. So like derivative of sine is what?
Cos x
Is cos. Cos, what is the derivative of cos?
minus sin x.
Minus sin x. What is the derivative of tan? Sec square x. Sorry, what is that? Sec square, is that right? Sec square. And that's all. This is I'm not going to go ahead with the trigonometric, that is not needed. The derivative of x to the power 1, x to the power n is n, x to the power n minus 1. And derivative of constant is 0.
Zero.
Derivative of exponential e power x is what?
E to the power x.
E to the power x.
E power x. Derivative of a power x is what?
A to the power x log a.
A power x upon log a, right? Or ln a, right? This one upon, I think so. Please check with this one. I think this is the one. Okay.
Yes.
And this is one. Exponential is done. Power is done. Trigonometric is done. Anything else is written? Anything
So
else? Log is there. Derivative of log is 1 by n, or ln. Here is not ln is there. Derivative of ln is 1 by x. Derivative of log, which is best in generally thing we think that. What is that formula? Derivative of that? 1 by x, then what? What is going to be? This is going to be ln. What is that? If you don't remember, we can make it here. I also don't know what is that. Let's do it here. This log x is actually log. So we can change this is ln x power ln 10, right? This we can do.
Yes, sir.
Yes, sir. Yes.
And derivative of this ln is what? 1 upon ln 10, and derivative of log is going to be 1 by x. So finally, derivative of log x is going to be 1 by x ln 10 also. If you don't remember, we can break in the portion of all of you know now. We can break in the in base form in the different with the different base. Yes.
I think for a to the power x, it's a to the power x into log a, right?
A to the power x is a to the power x and then log a in the multiplication
Into log a.
or into log n log a into log a.
Yes, sir. Yes, sir.
Or it is in the division form.
It's in multiplication form, right?
No, it
A
is
raised to x into log.
it is in the multiplication form, but if we are multiplying, it will be like this: log with base or log with base a and e. If you are writing in the multiplication, check it here in the internet itself. That would be good. Okay, in front of you, derivative of a to the power x. Oh, this is in the multiplication form. Okay. Okay. Oh. Here is, or this one is in the, okay, just in multiplication ln a, okay. Oh, this is a power x is, okay. So in the multiplied form, this is just, so okay, this one is, I think you said correct. So this is ln. So this one is, I think so. That's why I'm a bit confused. This one is going to be like this. Or in integration, it is a different. So that's why I got confused. Okay.
Yes,
so in
sir.
multiplication,
Sir,
ln.
can you just scroll up a little bit?
So please remember with the video lecture, whatever we have from there, you can see. Okay. Yeah, but my suggestion is please remember this one. So I'm sorry. My suggestion is please remember this one. At least remember, so that you may get some question in the that which to able to solve that. Okay. So we are discussing L'Hopital rule here, indeterminate form and then L'Hopital rule. So this is called yes.
Sir,
Yeah, hello, am I
wherever
audible? Your voice is breaking.
Yeah, sir. Sir, wherever we are getting the indeterminate form, it means that we are getting asymptote
Yes.
there. Is it so?
No,
Yes,
can
sir.
you scroll down?
Possibly, not always also. Asymptote, yeah, generally this is for, yeah, generally, sorry, my voice is clear, right, to all of you?
Yeah, your voice is okay, sir.
Sir,
am I audible
Sometimes
properly?
it is breaking, but
Because
mostly it is
somebody
clear.
is okay.
Yeah.
Yeah. Am I audible now clearly?
Oh,
Yes,
okay,
sir.
sir.
Yes, sir.
Sir, will a sharp curve have a tangent like a curve with a sharp point? Will there be a tangent to that point?
Just a minute, sorry, I am just making. Sorry, what are you saying? Could you repeat, please? Sorry.
Sir, will a sharp point have a tangent, sir, at this point? Like a curve with a sharp point.
At sharp corner, there is no
It's a sharp
tangent.
corner. Okay.
Oh, sorry. One by one, please, one by one. So, okay, let me finish this one. Okay. Or if you have doubt, please let me know one by one. So this form is actually, if this function is there, so in this form it is happening. So this is called indeterminate form. And once if you are in determinate form, then if you want to find the limit, just derivate then and then try to find the limit. For example, sin x by x. Suppose we have function sin x by x, and you want to find the limit at 0. Okay. So how we will find that? See that if you see here, sin 0 is 0 and 0 at x value at 0 is 0. So this is a 0 by 0 form. So this is a indeterminate form. So to find this limit, just derivate the same. The derivative of sin is cos, and
Cos x by 1.
derivative of cos, and the derivative of x is 1. So now find the limit as x going to 0. Now cos 0 at 0 is 1. So that's why this limit is going to be. Okay.
Sir.
Yeah.
Sir, I have a doubt. If in the indeterminate forms, like what we have to do if it comes like 1 power infinity in that form?
One power infinity, or it is finding
No, sir,
in
not
that
1 by infinity. 1 power of infinity. 1 power infinity.
Okay, in this fashion.
Yes.
So in that case, some standard, sir have given some standard in that limit case. Okay, some standard limit is given. Okay.
Yes, sir.
Otherwise, if not, then then even. But such question will never asked. Okay, if it is a very difficult, then it will never ask. Whatever you have whatever we have studied under the syllabus, the question will be. So such problem will first not ask. If it is asked, then surely it will be, sir have given some already the limit form, right? Limit, we can see there the list. We can, if you are asking that what is the list, so that list is actually on the here itself in the solve with assignment. Okay, please go through to revise the concept, solve with assignment, which is, I think, this one. After the week 8 of, I think, solve with us, or week 7. So both solve with assignment actually contain the proper and correct formulas of the derivative also, and indeterminate form. I think this is one tangent thing is there, function. So this is usable. You can think here the formulas we have for limit of the sequences, and this is the left and right limit. So I think in week 8 we have list of indeterminate form and the L'Hopital rule or standard limits. So this one here we have some derivative of what are the derivative formulas. So c prime or x to the power n sin ax cos ax e power x log ax log with any base a, and indeterminate form is here, and some standard. Is there any? No. Then some standard is you will get from the lecture only. The stuff is not written here. Okay. Like sir have given, that is standard form is also actually evaluated with the L'Hopital rule, like log 1 plus x upon x.
Okay, sir.
If you, this one is actually, it is if you check that as limit x goes to 0, this is a indeterminate form. log 1 value is
Yes, sir.
0, 0 by 0 form. Just derivate that in the numerator and denominator. What is going to be? Log of 1 plus x is 1 by, or this is not log, this is ln. So 1 upon, derivate there. If you derivate this one, this is going to be 1 plus x. Okay, and upon this x, limit as x approaching to 0. So this is 1 here. Derivate, if you derivate x is going to be 1. So this limit is finally limit x approaching to 0. This is 1 upon 1 plus x, which is 1.
Yes, sir.
So some standard
And sir,
limit
I
also
have
can
one
be
more
evaluated.
doubt. Sir, one more doubt. Like what will be there as the value of limit x tends to 0 cos x by x?
Cos x by x.
Yes, sir. As it's not coming 0 by 0 form.
Yeah, it is not coming as a 0 by 0 form. Then what is going to be limit in that case? In this case is limit exist or not. This is the problem we have. So indeterminate form will not help because this is 1 by 0 form is happening. So how I will get this?
So it would be not defined. Limit is not defined or does
Yeah,
not
this is
exist.
not exist actually. The limit is not exist here.
Sir, we can do like this now, sir. Like for cos x, we can substitute like 1 minus sin x, sin square x, and try doing like that.
So still that would not work, no? So this is the reason is actually, if you want to check it why the limit is not exist. So actually, sandwich theorem in the, okay, I didn't forget to tell you what is the sandwich theorem. By sandwich theorem, you can tell also. So what is the sandwich theorem? So sandwich theorem is, now we are in the limit. So sandwich theorem, I need to tell you that. Sandwich theorem is, suppose you have a function fx, gx, and hx. Okay, you have three function, and limit as x goes to a, this fx approaching to, let's say, b, and hx approaching to b, the same limit as x approaching to a, this hx is approaching to b. Okay, but there is an equality happening. This is this inequality for all x in some domain. Okay, in some domain, this inequality is happening. So sandwich theorem says that here is, suppose as x goes to a, fx approach to b, as x approaching to a, hx is also approaching to b. Then in this case, in this inequality case, gx will also approach to b. So as x goes to a, gx will also approach to b. Okay. Now let's see here how the I am going to use here the sandwich theorem. So we have cos x, cos x by x. And just now we seen in the starting, cos value is between -1 to 1, right? The range is bounded, right? In cos value will be between -1 to 1. Now we have this inequality. We can divide x in the both side, in the all three sides, like here, not three sides, in the both side of this inequality. Now this is our function. So here is also sandwich will not work here, because this is going to be infinity. This is goes to be minus infinity as x approaches to 0. Okay. So this is one problem. So by different way also we can do, as we have.
So sir, like for cos x by x, limit does not exist.
Limit does not exist. So also in different way also we can see that here this value is fixed, but this is going to be a what? Very large number. Sorry, this is approaching to 0 means 1 upon very large number is, 1 upon 0, very small number. 1 upon very small number. What it mean that it is going to be very large number. Another way, if you are not able to give with the proper explanation, then you can think as cos 0 is 1, and you are dividing 1 with the very small number, you are dividing 1 with very small number, then output will be what? Very large number. Then you can say that this approach is to infinity. That means not exist. By different way you can tell. Okay. So this is the sandwich also we have seen. Now let me tell you the one last thing is what? That finding the tangent line, tangent equation, equation of the tangent line and linear approximation. So suppose you have a function fx, let's say I'm saying x square plus 1, and the problem is what is the tangent, what is the equation of the tangent line at x is equal to 2. So how the formula? So same as we trying to know the differentiability definition, we are actually discuss with the tangent line. So, and this problem is actually finding that exact equation of that line. What is the equation of that line? As we there studying, when the curve is there, we are trying to know what is the tangent slope of the curve, means tangent slope of the tangent line. So what is going to be the equation of that line? We can also get the equation of exact line. So derivative is what? When we are trying to get the limit as h approaching to 0, f of a plus h minus f of a upon h. If this limit exists, and let's say this is L, so this L is actually slope of the tangent line. So see that we have the slope of the tangent line, and this point we have. So can we get easily the equation of the line also, right? As you know, once we know the slope of a line and at a point, so 1 point formula we can use, right? What is the 1 point formula? So exactly the same. What is the 1 point formula? Y minus y1 m into x minus x1. So this m is our f prime a, the derivative at a. And what is our x1? Our x1 is a. And what is our y1? Y1 is our fa, correct? No?
Yes, sir.
Yes, no. So this x1 is our a, y1 is our fa, and m is our f prime a, derivative of at a. Okay, that means here y is equal to, we can shift this form to this side, right? This FFA is can be written as f of a plus f prime a x minus a. Exactly the same, whatever we use there, the same formula we uses to find the equation of the tangent line. Now you can find easily, you can derivate this fx. Fx is going to be 2x. And at 2, this is going to be, derivative at 2 is going to be 4. So tangent at 2 is going to be equation of the tangent at 2 is y is equal to value of the function plus slope into x minus 2. So value of the function at 2 is going to be 2 square plus 1, which is 5. So 5 plus 4 into x minus 2y. So this is the equation of the tangent line at 2. Okay.
Yes, sir.
Now there is a ahead thing, linear approximation. So let me tell you the purpose why we needed linear approximation. Okay. So as we know here, the tangent is actually giving actually touches the curve at that point. So suppose we don't know the curve, but we know some line which is like this. Suppose some lines are there. Okay, suppose these are the lines, bigger lines. Okay, suppose these are the lines we have. Okay, so it is in this form is going. So if we just so try to think that, okay, this is actually a kind of curve is behaving like this. So linear approximation is what? Linear approximation is actually, suppose you have a curve, this one. So suppose once I found the linear approximation, I will tell you that how to find. So suppose I found at this point the linear approximation of this function means you are function approach this you are approximating this function linearly. That means by this way, by this way, by this way, by this way, you are actually approximating your function linearly. Okay. This is the mean. This is the use of linear approximation. We are actually approximating our function linearly around this point. Around this point, we are actually approximating or this function around this point. This is the mean of linear approximation. So there is a formula to find linear approximation, which is exactly the right side of the tangent line. There's also equation of this tangent line. So simply we can say linear approximation of the function, linear approximation of the function at A is which is denoted by LFX. This is a function. This is a function, and write the right side of this tangent. So see that there is x. So this is a linear function, no, in the variable of x. So this is a linear approximation of the function at A. This is the tangent, and the right side of the linear is the same.
Sir. Sir, once again, can you explain that the linear approximation definition once?
Why it is important, sir? Why do we need linear approximation?
So linear approximation is just now I was telling, no, you are approximating. Suppose you don't know. Suppose my question is, let's see the use. I will tell you again the definition of linear approximation. Suppose I am saying, I am writing a function fx is equal to 2x plus 5. This is a linear function, right? This is a linear function. Okay, or let me write this in place of fx.
Practice assignment week 6. Is it possible for me to ask her?
Sorry, practice assignment.
Practice assignment week 6. Is it possible for me to ask her?
So let me finish this one. No? Let me finish this one, then we can discuss that. Let me finish this one. So suppose we have a function this, and I am denoting with this function is this. Let's say fx. Okay. And this is the function we have. This is a linear function. I said this linear function is actually give the approximate value of the function gx around x is equal to 2. Suppose we don't know the function gx. We don't know the function what is the gx, but I said this function, whatever the function value at 2, you will evaluate at 2 what is going to be the function of f of 2, which is 4 plus 5, which is 9. So whatever you got 9 value, no. So the problem is, I just said this function is linear approximation of the function gx around or at A at x is equal to 2. It means that you are actually and now find the value of g2. I don't know what is that. We actually don't know the exact gx. So what is going to be g2 we don't know, but I said this one is a linear approximation of the function gx at 2. That means this value will be approximately 9. Approximately. It may not exactly, not equal to also. May not exactly equal to also 9. But it is somewhere around that. What it means that? It means that if you are, suppose you are drawing the graph of the function, suppose this is the graph gx. So at 2, if you get the output, you will come around. It will come around, suppose here is 9. So it will actually see that it is coming around the 9. We don't know exactly, but it is somewhat, it is approximated the value of the gx, the function gx. This is the mean of linear approximation in different method. You are approximating your graph linearly. You are try to get the value of the function linearly at that point. Now it is a bit clear to what is the use of linear approximation.
Sir, linearly means parallel to the
Linearly means
x-axis.
using this function. Linearly means using this function. Using this function. If you have a problem with that, because this function is a linear function, that's why linearly approximating. Otherwise, linear means this function. You are approximating your function gx around 2 by this function. By this function means to say, we don't know gx, but we are approximating our gx around 2 is by this function. Even you can say that gx is exactly fx around, you can say around x is equal to 2. Sure, there is a problem. Still, by this way also you can say you are approximating the gx is exactly or approximately equal to fx around x is equal to 2. This is the mean also. This is the mean of linear. Sorry.
So that point can be,
Sir,
as
2.
you said, that around x is equal to 2, and in the graph you said the point 9 there is, it is on the y-axis. Then we can say that y is equal to 9, around y is equal to 9, and over above the graph you wrote around x is equal to 2. So approximation can be anywhere at the x values and the y values.
No, here I think you confused with this one. Here is now 9 values. So see that here our value is this one, no? So y value is coming around 9, no? This is the 9. Suppose here is y value is this one. This is I think 9.5 or 9.2. It is coming around the 9, right?
Yeah. Yes, sir.
So maybe an
In
example
other
would
ways,
help.
there is if you are confusing, if you are getting confusion, that you simply this definition is the best way to say that we don't know the gx, but I said this fx is a linear approximation of gx at 2, means your function is actually approximately equal to around 2. This is the one way also. We don't know this expression, but by this linear function we can say that this at x is equal to x is equal to 2, our function gx is somewhat approximately behaving like this linear function. Okay, this is another way you can say, and this is also a best way. Means approximating means your value, whatever the value of gx at 2, you'll get around 2. Similarly, this is a very similar to fx at 2, fx value at 2. So if you are, it is much confusing. The question will not ask me in the what is the exact meaning. So you can remember this formula if you are still getting. So please think whatever I just
Can you
said.
give an example for it by this formula?
So by this formula, exactly this one, I just said here is find the tangent line. Now again, suppose fx is equal to x square plus 1, and find the linear approximation of the function at x is equal to 2. This is the question we have. So how we will find? We'll use the formula L of x is equal to value of that point, derivative at that point, x minus 2. Now it is easy. F2 value is 5.
2 is a.
Sorry, 2
Sir,
is our
X
A. 2 is our A. This formula.
That is given in our question.
That is given in our question. A value will be given in the question.
Okay, sir.
That means, sir, a linear approximation and equation of tangent is same.
Not same. That is, see, equation of the tangent is equation, but here linear approximation is a function. Linear approximation is this is a function, but this is a equation. So there is a much difference. But yeah, I am saying the right side of the equation is the same as the linear approximation. To remember yourself, otherwise if you are thinking these two are exactly different, I am just telling about because you may remember easily that right side of the this equation of the equation of tangent is exactly same the linear approximation of right side of the linear approximation. I just said because of to remember easily, otherwise there is a much difference, or this is an equation and this is a function. So lots of means there is lots of difference. Exactly different. I just said for to remember easily, that's it. Otherwise there is no relation.
Linear approximation will always give a particular value, a real value.
So can we also ask
Linear
the doubts now?
approximation is a function. Sorry.
Can we also ask the doubts now?
Yeah, now I have almost done. I think now linear approximation is done, derivative is done, differentiability is done. I think nothing is remained now. That sandwich is done, sequence series, derivatives, almost we have done. Yeah. So now I will take your doubts. What's your doubt? One by one, please ask. We'll take your doubt and then close the session. Almost I have whatever the concept I will try to revise. Almost I have done. So,
please explain again the sandwich.
So practice assignment 7, week 7, question 1. I have 5 doubts. 4 doubts actually.
So please go through the solution. No, if you have doubt in the practice and gradient, please once watch the solution, then back to me, because practice solution is there. If you are not getting, then I will discuss.
There is no solution for week 7. Sir.
No, practice solution is uploaded. No.
No, sir, but
no. Just a minute. Let me check the practice assignment solution for week 7. It is there.
I'll just check it out. But could I just explain it? So it will be easy.
This one is the practice assignment.
Okay, sir. So, but can you just explain the questions? So it will be easy to understand.
Okay, which question number? Which question number?
The first question.
First question. Okay, this one. The graph of some function is drawn below. Choose the set of correct statement. Limit of the function at x goes to or x tends to 0 is 1. X tends to 0 is 0. So here is what you are not understanding. What are you not? You are not getting.
No,
Which
sir,
option?
Can you just explain all the options? It will be better.
So like option is the first, like first option if I take here, limit of the function. So this represents a function first. This is a graph of a function.
So this one I understood. So the tangent question.
Tangent. Where is the tangent? Okay, this one. There is a unique tangent at point x is equal to pi. Here is pi, but not at minus pi. So what is the tangent at there? This is not a soft corner. This is a smooth one. So
Yes,
tangent
sir.
is exists, right? This is the same axis x-axis itself.
Yes.
This is a smooth one. This is not soft corner. See that this is smoothly going like this. Smoothly.
Yes, sir. Got it.
So tangent is actually unique, and unique in the sense of, see at here only this line is touching. If you try to draw another line, there is no possibility. Only one this line x-axis is the only touching, only touches the curve.
Yes, sir. Got it.
That's why it is a unique tangent at pi and minus pi and even at 0 also.
Yes, sir. Sir, and question number 2, I just want to know how to write n power 8 by n, sir.
This one.
Yes, sir.
How to write? How to write?
N power 8. Actually, for me, the question is different, sir.
Okay.
Shall I share my question then?
Yeah, what is your question? You can tell it, sir.
Consider the sequence, like it is all the same, sir, but only b of n is n power 8 by n plus 3n power 1 by n minus 1.
Oh, maybe here is changed. Here the expression is changed only, no?
Yes, that is only.
So then if it is n to the power 8 by n, then you can change, right? You can think at this is, you can, like, here is, if you want to solve this problem, how will solve? Like this one itself. N to the power 4n is there. So this n to the power 4, when, how we can write? 4 1 by, sorry, n to the power 1 by n whole to the power 4 we can write also, right?
Okay.
By this way you can do.
Sir, fifth question.
This one.
Yes, sir.
So again the same way as here the an, this limit is given as e. If this limit is given as e, so what is going to be the case for limit when in place of n, we can write 3n, 4n, 2n, 2n plus 1. Still it will be the same work, right? It will be work as same as we, if you see the here the definition, or let me show in the solve with us, it will be more better. Cursor is taught there already, so let me show in the solve with us assignment. So here is, or here is, so if an is approaching to a, then f of an will also approach to f of a, right? If an approaches to a, so in place of n you can substitute, here is what is a f of an or f of a is actually 2n kind of, or 2n plus 1 kind of is happening, correct? So only the places change, only the inside thing is changed. Either it could be 3n, 4n, 5n, any n, but still it is behaving. If it, the format, if you see that, the same, the format is exactly the same of whatever you have this one an structure. You see the structure of this an, this is exactly in place of n, only 2n plus n is written. See that here, and in place of again here n, here is 3n is exactly in the same way it is written. It is happening with the same as just now showed you in the solve with us. So still this will go to the same limit f of.
But can you just solve it, sir?
Here is, okay, let me first, this limit is, or no, this is a subsequence. No, this is in subsequence form. Okay, I showed you in the different way. Where is the solve with us? Okay, this is in subsequence form. Okay, if, okay, so let me tell you that if an is sequence, okay, then if an is sequence, then a to n means here is, suppose I'm writing sequence n square. Suppose an is n square. This is a sequence. Okay. In place of n, like if you write this term, the terms will be what? 1, 4, 9, 16, 25, 36, like this. So in place of this one, I took only what? 4, 16, 36, 64. So these terms I took. These terms I took. So this is a subsequence of this sequence. This is called subsequence of this main sequence, right? I took the some terms. I took sub terms in the arranged form, and this is called a subsequence. And if the limit have whatever the limit, this has limit, no, the original sequence have limit, the subsequence also have the same limit. This is the definition. If you see that, if you see there,
okay,
the subsequence definition have the same limit. Now see the question now. There Here is in place of n, it is I took here 2n kind of thing, right? 2n whole square. And there, if you see that in place of n, it is written 2n plus 1, which is also a subsequence. Odd terms you are taking in that sequence. Here is I am taking even. Odd term also I can take 1, 9, 25, which is 2n in minus 1 or 2n plus 1 also. We can think here is 1 is started here. So that's why 2n minus 1. So I am taking in the sequences 2n minus 1 odd terms I am taking. So this is a subsequence of this n. And subsequence have the same limit whatever the original sequence had. Okay. Is it clear
Sir,
now?
Okay, sir.
In subsequence, we will not take the same values 2 times. Is it? Can we do that?
In subsequence, can we can take 2 values at the same time?
Same values, sir. If in the question we have same values like 4 is there 2 times, then in subsequence we will take 4. Can we take 4 2 times?
4 2 times.
Actually unrelated to this question. Generally, I'm asking.
Yeah, I'm getting it. I'm getting it.
Yes, sir.
So what is the subsequence definition is? What is the definition of subsequence? If you have a sequence, if you take the some terms common, suppose you have this sequence, okay, this is the sequence you have. If you take the terms, if you take the subset of the terms, I mean here the subset of this sequence means, sorry, if you take the some terms in between and arrange in the same order, that is called the subsequence.
So, but for this question, the answer is given as 2.
Sorry. So in the subsequence form, you only take the, like you are taking the terms, you are taking some terms and making in the same arrange. So you cannot take, right? You cannot take 4 2 time or 16 16 or many times.
So can you just explain this question or solve it, because answer is given as 2.
So answer is given is 2.
Sir, and also question 4 and 8, these two ones.
Where is that problem?
So that one I'll do it. So question 4 and 8.
So fifth is done. Fifth one is done. This one.
No, sir, but I will try it out. Only just for question 4 and 8.
So this is log. No, this is in log and this value is there. Log and this one. This is the same sequence. Limit is what? What is going to be limit here?
It will be E.
If you have a log, a sequence n, suppose an is going to be sequence a, so log an will go to log a, correct?
Okay, sir, got it.
Now it could be done, right?
Yes, sir, got it.
Okay, I took
Question 4 and 8, sir, only these two.
Okay, so again, if you've gone through the solution one, or you are okay, because you are only the asking doubt, maybe I'm not giving to the anyone else have chance. Okay, so here is if an and bn is both convergent to some non-zero real number, then a and bn also convergent to some non-zero real number. An is a sequence, bn is a sequence. Okay, both are converging to some non-zero real number, then a and bn can also converge. Some non-zero real number. Let me take, suppose I am taking a sequence an. I'm taking a sequence an is equal to 1 by n. Okay, and bn is equal to Bn is equal to some another sequence. An is 1 by n. I'm taking 1 by n, and Bn is let me take once. An is convergent to some, Bn is also convergent to some non-zero real number. Then An into Bn also converges to some non-zero real number. So this is in multiplication, it is given there. So did you go through the solution? Let me say some example will be given there. There will be easy. It is easy for me to also to see there. What is the example that? Okay, this is from the graph.
This is question
Clearly,
one.
this is the question one, no?
Yes.
Okay. Internet is there.
So then I will ask tomorrow.
Sorry. So this is this in this problem you just need to take some examples. This actually that is statement is not true. I'm this time not getting some example of sequence AN and BN. If you see the solution, there is written already. I have taken some example. I
Sir, I
think
will just find it out. Sir. Question 8. That's
okay. In question 8, where is that question 8? This one. Okay. If if Rana wants to book the studio for 2.6 hour and he chooses the scheme to avail the studio in minimum cost, then find out the cost he has to pay to book the studio for 2.6 hour. To book a studio for this much time, and he chooses the scheme to avail the studio in the minimum cost. Okay, then find out the cost he have to pay for the. So these are the scheme, no?
Sir, actually I understood everything. I just have doubt. What is the difference between the first one and the second one? I just want to know which one is the floor function and step function. That's all.
Sorry. Could you repeat, please?
Sir, I know like we have to choose a lower 100 into 2 plus 200. I want to know whether it is first scheme A or scheme B, sir.
So that's why you need to substitute, no? Just if you substitute the value itself in 2.6 in 1 by n scheme A, B, and C, then according to that you will choose that how much time
I
it
will
will
go for
take.
scheme A and B, sir, because
Sorry, where is this?
Scheme B is a ceiling function, a ceiling 100, ceiling of 100 T.
Yes, sir, that's what I wanted to know.
So this means that if you give 1.5, this value is 1. If this means that if you substitute here 1.5, this gives 2. This is the ceiling function, this is the floor function. Floor, this is ceiling.
Yes, sir.
Okay. So if you substitute here, like here is 2.6 is there. So for ceiling 1, this is for floor 1, this is 2. For ceiling 1, this is going to be what? 3.
Yes, sir.
This one increased.
Yes.
So ceiling, if you see the definition of ceiling function here is written, denote the smallest integer which is greater than or equal to t. Smallest integer. So 3 is the smallest integer which is greater than this number. Is there any another integer which is greater than this one number? No, this is the smallest integer which is greater than this number. This is the floor. Sorry,
Sir,
this is the ceiling.
Week 7, activity question number 3. Activity 3, question 9.
No. So I will take later your doubt. Let me check anyone else have doubt. Then I will take. Otherwise, you are asking like you are continuously asking doubt. So anyone else have doubt?
Excuse me, sir.
Yes, see that many have. So yeah, one by one, please ask. Please raise your hand first.
So should I tell it or I'll wait?
Yeah, so okay, Shreya is already asking. I'm not going to take your first.
He was
Now
someone,
next is, sorry.
he was someone else. I wasn't asking.
Sir, I was
Okay.
asking, sir, all my doubts are clear.
Okay. So yeah, Shreya is okay. Then Shreya is okay. What's your doubt, Shreya?
So week 7, activity question 3, activity 3, question 9.
Week 7, activity number
3,
okay.
question 9.
Question 9.
Yes, sir.
So this is the definition of graph only. Let you have a be a function, okay, from set A to B. Which of the following option is true? Cardinality of the graph. The graph is the same as the cardinality of A cross B. So what's your doubt here?
Sir, I'm not understanding the question.
So in this problem, a function is given from set A to B, okay. What is the definition? So that's why I am asking, what is the definition of a graph? This, what is this sign?
This is for the graph.
This is for the graph.
Yeah.
So what is it like here is, if you have this graph, so graph is actually what? Can you tell me what is the definition here? The graph in mathematical format. What is that? What is that? X, f of x, right? Graph is nothing but a collection of point where x belongs to A, right?
Yes, sir.
This is the definition of graph.
Yeah.
But what is going to be here now? Now this is the graph. So if you count the cardinality here, so suppose our case is here, from our graph is A to B, from set A to set B. So what is going to be the graph of this in this case? So what is this set is there? What is this set? It is written in the pairwise. Suppose I am writing here, fx, I am writing a function, fx is equal to, I have a function f 1, 2, 3, and outputs are this one. So graph of let's say this is A, B, C. So graph of the function, what will be the graph of the function in this case? 1A, 2C,
3B.
3B. This is the graph of the function.
Yes, sir.
So what is happening here? This multiplication is happening by?
Yeah.
Is this multiplication is happening or just in the pairwise it is written?
We are writing x and y in pair. X and y coordinates in pair.
So which option is now here? Can you tell me which option is going to be? It is going to be cardinality of exactly A cross B, or cardinality of A, or cardinality of B, or cardinality of A cross B, or lesser than the cardinality or equal to cardinality of A cross B. What is here? Is it happening in multiplication format? If you multiply A and B, so how many numbers or how many pairs is going to be there in A cross B? How many pairs will have A cross B?
So there would be 9, which is not the case here.
Yes, there would be 9, right? Do you know that multiplication of two sets?
Yeah. Sir, I know.
So here is happening the same. Here is multiplication happening for two sets. So there is 9 is happening, but we got that the graph is this one. So
Yes,
this is
sir.
3. So what is the cardinality is happening with respect to?
A.
A, right?
Yeah.
So now can you choose the correct option here?
So that will be option 2 and 4.
So the cardinality is going to be the same as cardinality of A, or it is going to be lesser than the exactly of, or less than cardinality of A cross B, because A cross B have seen have 9 and graph have lesser than 9. So maybe lesser than 9, graph of the cardinality of 9 is lesser than 9.
And sir, can't be third option correct?
Why? How it could be correct? Suppose I am writing again this, I am just given another D is here. And D is, there is no D, there is no map of D.
Yeah. Okay, got it. And so one last question is there. In week 6, activity 5.
Which
Week
activity?
Activity 5, question number 1.
So this part I am just leaving for you. I will provide the video link there, how to find the log form, how we'll use log to find the number of digits. That would be better to know. It is easily tells you that how it could be, and also with the region. So just you can search here exactly easy way how to use log to find the number of digit. It will be much easier in place of I am just whatever I will explain here.
Okay, sir, I will search it.
Yeah, just search that how to find the number of digit. It will number of digit in A to the power B case. There are many examples using log. You can see that using logarithmic. The first one even itself tells you that how to find it. Okay. It
Okay,
can
sir.
easily tells you that.
Sure, I will search it.
Yeah. And in a better way, whatever I will tells you, in a better way, here is the already spended much time to tell you that here is approximately 4 minutes. Easily can get.
Yes, sir.
Okay, this is one we done. Okay, let me see who is next one. Shreya is done. Ronak, what's your doubt?
Sir, I just wanted to know that are we going to get week 1 to 4 questions in quiz 2? Direct questions.
So in as my answer is that you will not get the directly question, but yeah, the concept may be used whatever you studied in week 1 to 4.
Okay.
It will be not, you will not see the question like find the number of turning point in the this like this, or find the number of root of this. This is the direct question of the polynomial, but you will
Yes.
not see like this. Yeah, maybe while solving in the critical point is in the week 9. Okay, so while solving, maybe the polynomial will be used there. Some polynomial concept have used there. So indirectly you can see week 1 to 4 is there, but not direct.
Okay, sir. Sir, and what will be the total number of questions for maths?
It will be roughly as 10 approx, 10, 12.
12.
Yeah, 10 or 12, because maybe some question have some part also. Okay, some part like A and B part. So maybe because of that number may increase. Otherwise, exactly the number will be 10 or 12 roughly. 10, 12, 13, lesser than 15.
Okay.
Yeah.
Sir, and one more doubt. Sir, what is the difference between differentiability and differentiation?
Differentiability and differentiation.
Yes, sir.
Okay. So differentiability generally, like the question will be asked, the function, this, suppose you have a function, okay, and suppose this is the expression of the function.
Yes, sir.
So I just ask that, or even the same we just now discussed, no, x minus 1 at the mod function. This problem is, will be asked, is the function is differentiable at 1 or not? So what you will do, you will check that is limit is exist at this limit is exist or not. This
Yes,
is the
sir.
definition, means checking is the function is differentiable or not. So only you will check is this limit is exist or not. And what is the differentiation means what is the exact limit. This L is actually differentiation at 1. The value at the value of the function is actually value at the limit is actually differentiation at 1. And if limit is exist, then you will say the function is differentiable at that point.
Okay.
This is the difference.
Okay, sir. Sir, are we going to get questions from chain rule of differentiation?
Maybe I'm not say may not. Means I will not say it is not there. Maybe, but I will suggest you please remember those formulas. Okay, even the chain rule also. The chain rule is what? Nothing but if your function has suppose sine 5x is there. So if what is the derivative of this one is cos 5x. Okay, and then derivate the inside 5. The derivative of 5x is 5. So 5 cos 5x.
Okay, sir.
So maybe it can be there.
All right, sir. Thank you, sir.
Next one is what is the name? DHBC. What's your good name?
Sir, I have a question.
Yes.
Sir, in activity 8.2, question number 10.
Activity 8.2. Question number
10. Last one.
this one.
Yeah, how to find out the K, value of K.
So one by one, just first time say this. We have this function. It's the first in the first is if function is continuous, and another one is if the also the function is differentiable at 1, then find the value of this one. Okay, so how we'll solve this one? You know, function is continuous means what? Left limit is equal to right limit at 1,
yes.
and also the function value equal to. So if you find the left limit, right limit, and function value, you will get some value or you will get some relation in K and L, or even you can exactly find the value of some K or L also. And now if you once again use the differentiability definition, just now this definition in place of exactly this one, if you according to substitute in, yeah, exactly differentiability is also asking at 1. So in place of this f, you can in place of this function use this whatever we have the function and substitute here accordingly and find the limit and and here once you start derivating, so what I said, you have this limit, then you have to find the left derivative and the right derivative, left limit and right limit. Okay, this is the we said, right? Are we there or not? Yes, when we are discussing? So left limit and right limit you have to find, and these two should equal to, both should equal to. So once you find the left derivative and right derivative and equate them, you will again get a relation between K, L, or whatever the variable is there. Using that you can get exactly, or K and L, Km is there, whatever the.
Got it.
Yeah, okay. And also using the continuity, also left limit, right limit, and value of the function, you will get some relation between K and L. Solve that relation, you will get easily the value.
Okay. Thank you, sir.
Next one is Danya. Yes, hi. What's your doubt? No one is there. I think she left. Hello, Danya. Okay. Anyone else have doubt?
Sir, week 8 solve with us is not there.
No, week 8 solve with us there. Here is before the tutorial.
Okay, sir. In my not showing this.
No, it is actually showing. Just check with the tutorial, above the tutorial. Once the actually activity 8.4, below of activity 8.4.
Okay, sir. So it is helpful for taking idea for exam.
Yeah, it is actually a kind of a quick revision, no? Even it contains some formulas also. See that this contains what is the differentiability in a short form. You can remember, you can revise your, or here is some day specific type of derivative is given, like composition or sine, cos, e power x, log e. These are some formulas also contains. So it is a quick revision you can do if you want. If you want, it's totally up to you. If you are made your note, then I will suggest you go through your note only.
Okay, sir.
Okay, so anyone?
Sir, how can we know a function is bounded or not if graph is not given?
Graph is not given, then how we know that function is bounded or not?
Yes, sir.
It's like the function will be given. No, at least function will be given.
Yeah, the function is 1 upon x square plus 2.
1 upon x square plus 2. Is this function is bounded or not?
Yes, sir.
By finding the range, sir, can we?
By finding the range, if you want to find the range, you can decide easily also. What is going to be the range? Yeah, only that way you can tell. So what is the range of this function?
0 to infinity. No.
No. Yeah, that's the thing.
Hmm.
See, only what is that? See, this is whatever the number you will do, it is always positive because x square plus 2. Just see carefully, right? This is always positive. Any number, and you are dividing one with that number. So what is the possibility that it could be maximum reaches to n? See, this could be exactly reaches to, it could be 1 also, but we don't know. So either if it is 1, then this is going to be s square plus this is 1. If we assume that this is equal to 1, so that means this is going to be -1 is here, x square is equal to -1. So 1 will never attain, as if you take the root of it, you will get I.
Yes, sir.
And so that means the value will never go beyond of no, always it will be lesser than 1 because you are dividing 1 with that some particular number. And also, what is that? It will be very close to 0 if you substitute very large number.
So that will be 0, 1 upon infinity plus 2.
Yes, it will be very close to 0 in that case. So what is happening here? It is kind of bound there in below and above, right? The value will be never go beyond of 1 and never go beyond of 0. Not lesser than 0 and not greater than 1.
Okay, sir. Thank you.
So by this way you can think. Okay, let me check anyone else. Then I have left.
If we get infinity at any side, then it is not bounded, no, sir. One infinity at right side. For example, minus infinity to 1.
Still, it is very close to 0, no? If you are getting infinite x in place of x, you are means you are substituting very large number. So 1 upon very large number means 1 plus 1 upon very large plus 2 means still very large. 1 upon very large number is again very close to 0, right?
Okay, sir.
Sir, I think he's not talking about this function. Like any random function, if we get range as infinite number, then he is asking.
Yeah, sir. Range, about the range.
So could you repeat, please? Again, I thought maybe this one.
So as it is written in the round brackets, no, 0 to 1. So if I get here minus infinity to 1, then also we can say it is
no,
bounded.
then it is not bounded. The definition of bounded means there will be bound, there will be a fixed number both side in. This is a real number, this is another real number. This should be two real number. If any one of is infinite, if anyone is infinite, then that is not a bounded case. No?
Both
then it
sides
is
real number.
you're actually infinite means not defined, and you are actually closing open. That this is open side, open interval means this infinite means this sign is actually your number is not defined. That's why this sign is given.
Okay, sir. Okay.
Okay. Anyone else? Like the next one is DH
Sir,
87.
I have one question. Limit x tends to infinity, square root of x square plus 10x and minus x. How to solve this, sir? The whole square root of x square plus 10.
Sorry, could you repeat? Sorry, what is that limit?
Limit x tends to infinity,
Okay.
square root of x square plus 10x minus x.
That's all.
Minus x is not into the square root.
Okay, minus x is here.
Yeah.
Okay.
How to solve this, sir?
So this could be like you need to do the rationalization. No? If you do the rationalization again, like here x square plus 10x is there. Okay. If it is there, so minus x, multiply both sides, x square plus 10x root over.
But here they have not given anything equal to 0 or any value.
Equal to 0 or n value means where it is?
Means there is no value. We don't have two sides, left hand side and right hand side.
So here is not left hand side. Here is only one way. You are approaching to infinite only this side, no? There is one way, only one side left from. If you are approaching to 0 by this side only, from left to infinity. So there is no left and right. Only one way is there.
Then we have to multiply by the same value and divide by same value.
Yes.
Then again it will be complicated if I am dividing
No.
the.
So let's see that. I don't know. Let's see that. So this is going to be x square plus 10x, and this is going to minus x square. No, it is not going to be complicated. It is becoming a easier case, no? This x square going to be cancelled out. This is 10x upon root over x square plus 10x plus x is here. Now we can take x as in numerator and denominator common, or in from denominator you can common. So x is common, then what is going to be 1 plus 10 by x plus x. Sorry, here is 1, not x. Here is going to be 1. So now as x goes to infinity, what it means that 10 by x, where it will go? 10 by x, this one will go to 0.
0, yeah.
So finally, what is that? 10 upon 1 plus 1. What this one is there, another one is there. 10 by 2, which is 5.
Thank you, sir.
Yeah, so by this way, yeah, so rationalization is if it is a such problem, so rationalization is an important thing.
So we have taken x square common in the denominator.
Yeah, x square in the x square, not x is I take common in denominator, but if you take the x common as denominator, so inside of the root I have to take x square common, then root of that will be x.
Okay, yes.
Okay, so I think now I'm going to close the session. It's 3 and
Thanks a lot, sir.
Yeah, sorry. Yeah. So thank you so much. I don't know. I have tried to revise your concept. I hope all of you over there got some revision. Okay. Best of luck for your exam. I am from my side, I am saying if you're okay with at least bit, the paper is not tough. So I think we will do easily, all of you. The paper is not tough. Okay. Yeah.
Thank you, sir.
And please, at least from my side, please go through the finding the equation of tangent, different types of derivative, like we said now, what is the derivative of sine, cos, tan, e power x. So revise that all, and some limits, and linear approximation, and some that log, and try to solve the log equations, in algorithm, log exponential equations, logarithmic equations. Okay, so try to solve, practice similar question, you will get that. Okay.
Sir,
Yes.
can you just solve practice assignment 8, question 6 alone?
So practice assignment is not, I'm going to solve practice assignment formally, because you're asking practice assignment. Already solution is there, no? So did you gone through solution?
No, sir, actually, solutions are difficult to understand. Sir. Understand means if I know the concept, it is, but this problem is slightly.
Which practice assignment?
8, question number 6.
What's your doubt here?
So,
Here is
can I
says
just, sir, I
you
understand
need,
the question also. I just want to solve.
so solution part, then let me tell you that now the solution is here. Oh, this is again it bit disturbed. Internet issue. Okay. And that problem now, see, it will take time. So, but if you see here is for, you have to find the ft. If it is saying to be continuous, means at t you have to find the left limit and right limit. Similarly for gt, you have to find left limit and right limit. This is a floor function. What is going to be limit? What is going to be the left limit? Which function will work for ft? Are you there? No, things he left. Okay.
Sir,
Yes.
actually, I was having a problem. No, so that's why, sir, I do not know how to find the limit of this function. That's why I'm struggling.
So that's why I'm asking, what is the left limit here? What is the left limit? Which function will work?
0 by 0 form. So
Is
we
this
can do
0
L
by
Hospital's
0?
rule.
Yes, use the L'Hopital rule now for the left hand side, for the left hand side at least. Then in that case, are you able to evaluate the limit using the L'Hopital rule from the left hand side, from the left limit?
Yes, sir, I'm just doing.
What is the right limit?
N.
What is the right limit? 3. It will be 3. So 3 equal to whatever you evaluated the here, which is n something is there. So you got the value of n now. Or it could be 2n or something will come. Okay.
Yes, sir, got it. Got both.
Yeah. Also, please go through the solution, because in the solution, L'Hopital rule have used. Maybe if you are getting the concepts, then easily can get once you see the solution. I think you can do. Similarly,
Yes, sir,
here is
understood.
also L'Hopital rule. You can apply for the left hand side, and for right hand side, is just substitute the value.
Yes, sir,
That's
got
all.
it.
And compare. Okay. Okay. Now I'm going to close session. It is more than 3 hours, 3:30. So thank you so much. Best of luck for your this quiz too. Okay.
Okay. Thank you, sir.
Thank you, sir.
Thank you so much.